This conference will now be recorded.
Hello everyone, is my voice clear?
Yes, very clear.
Thank you for the confirmation. A very good morning, afternoon, or evening to one and all present here virtually for the day two sessions. Let's start the session with presentation from Lillian and Hyun Park, University of Canterbury, New Zealand. The presentation title is Enhanced Degradability and Mechanical Properties of Biodegradable Plastic Composites with New Zealand Jade Waste. May I know who is presenting now? Is it Lillian or Hyun Park?
I'll be presenting Lillian.
Okay.
So everyone can hear me, is that right?
Yes.
Can you hear me? Sorry, can you hear me?
Yes. You can start.
I'm so sorry, can you hear me?
Yes, we can hear your voice and the slides are visible too.
Thank you. Sorry about that. So hi everyone, my name's Lillian and I am from University of Canterbury, New Zealand. I'll be presenting enhanced degradability, mechanical properties, flame retardation of PLA composite with New Zealand jade particles. And in this presentation, such properties would be evaluated. The motivation of this research is to consider the possible directions in managing the detrimental impact of plastic pollution that is in such an apparent level that even geographically remote regions like New Zealand have microplastics being detected in the environment, that we really should come up with fast and effective solutions to save our ecosystem. One of the possible solutions would be utilizing biodegradable plastics, which has the prospect of reducing environmental harm through ability to degrade over time. However, they have their setbacks that we acknowledge, but we should overcome. For example, PLA polylactic acid, which is one of the most used synthetic bio-based plastics in many industries and applications. However, they exhibit lower mechanical strength if they were to be recycled, hence such approach is inhibited. Additionally, the degradation of biodegradable plastics can be slower than initially anticipated, raising concerns about their overall effectiveness in reducing environmental pollution. Consequently, both factors contribute to the slow adoption and integration of biodegradable plastics into mainstream usage. To address these limitations, our research aimed to investigate the incorporation of New Zealand jade permanent particles into polylactic acid to utilize the 20 to 30% of jade waste generated by carvers, artists, and designers where they eventually dispose to the environment. I'll talk more about the aim and objectives on the next slide. The overall aim of this research is to develop a biodegradable composite that would not only reduce the amount of waste in our environment, but also decrease pollution. This required firstly studying how to compound PLA with NC jade particles to enhance overall composite performance, then examining the material properties of the developed composite with various analytical techniques. We'll also explore the composite compatibility with 3D printing technology and compare with the compression molded composites. I'll give a brief background about the materials that will be used to develop the composite. PLA would be used as the base polymer matrix to develop the composite which is obtained from the US. As for NZ jade particles, commonly known as the greenstone among early European settlers and pounamu by indigenous Maori people, there are two types, where one of them is nephrite jade, which is more highly valued for carving, and the other type is called translucent bowenite. Such jades are delicately carved into tools and weapons for historical warfare and jewellery. The jade waste we used to develop the composite were from Hokitika. For this study, we would be analysing the chemical and physical structure of NZ jade particles using XRD, XRF, EDUX, SEM. PLA that would have NZ jade particles incorporated via extrusion, becoming composite pellets, would be extruded again to produce the filaments used in 3D printing, and the composite pellets would be compression molded to compare the chemical, mechanical, rheological, and thermal properties. On the next slide, I will briefly discuss the techniques to evaluate NZ jade particles. X-ray diffraction is used to determine the mineralogy of pounamu. As for X-ray fluorescence spectrometer, it determines the pounamu chemical compositions, specifically the oxide content. Energy dispersive X-ray spectroscopy was used to determine the elemental composition and distribution of pounamu. From scanning electron microscopy, detailed pounamu structure images were obtained and used for screening to attain the particle size distribution. In the next slides, we will briefly talk about density, thermal stability, and partial degradation measurements. Pygnometer is used to determine the density of the 3D printed and compression molded PLA pounamu strips. This ASTM standard test method here was used to implement the flammability tests of the 3D printed PLA pounamu strips, and its linear burning rate is expressed using this equation here. Thermogravimetric analyzer was used to determine the thermodecomposition behavior of PLA pounamu composite pellets, and their normalized residual mass is defined using this equation here. Rotational rheometer with parallel plates was used to implement time sweep tests to determine the thermodegradation of compression molded discs. Time sweep tests will be able to determine the complex viscosity, which will be normalized so the changes in the complex viscosity would be independent of the specific amount of jade in each composite, and this is defined by this equation here. Using the model below, the complex viscosity can be inferred to quantify the thermodegradation, which is the molecular weight, decreasing with time. In the next slide, I will briefly discuss the tensile and 3-point bending properties that would be evaluated. So tensile and 3-point bending tests were performed using a universal test machine. The tensile properties such as tensile stress, strain can be determined using these equations here. For Young's modulus, is the slope in the tensile stress versus tensile strain plot within its linear regime. Toughness is the area under the curve of the tensile stress versus tensile strain plot. As for 3-point bending, this ASTM standard test method was used to obtain the flexural stress, strain, strength, and these properties are defined here respectively. Similarly to Young's modulus, flexural modulus is also the slope in the flexural stress versus flexural strain plot within linear regime. Next, I will talk about the results starting with the NZ jade structure and obtain particle sizes from SEM images. NZ jade particles show diverse structures, including chunks indicated by the green circles here, needles, and plate-like structures enclosed in the blue box. Some of these structures appear fused together or close to each other. The composition of the plate-like structures, whether they consist of needles, remains unclear. However, it seems that the shorter needles may have originated from the longer ones through the grinding process. This means that the grinding process of NZ jade results in ground pieces of varying sizes. highlights the importance of screening for the desired sizes to ensure consistency, especially when you're trying to study their chemical and physical effects. Majority of the NZJ particles were 38 micrometers or smaller, and with a smaller amount at various sizes between 38 to 212 micrometers. Next, we will briefly talk about the XRD, XRF, and EDUX results. From the XRD spectra illustrated here, visible peaks of tremolite in green and small amount of calcite in red being detected in New Zealand jade. The presence of tremolite explains the natural green colour observed in New Zealand jade, while the presence of calcite explains the slight white tone that is observed. As for XRF, various oxides such as magnesium oxide and calcium oxide, etc., has been detected, while EDUX detected oxygen, silicon, magnesium, calcium, iron, and aluminium elements, which validates the oxides detected in the XRF. Next, I will briefly talk about the density and appearance of the compounded strips. So density increases with the amount of compounded jade particles for both 3D printed and compression molded strips. It was found that the 3D printed strips has density 2 to 13% lower than compression molded strips. This is actually expected because the applied pressure in compression molding of the strips minimizes the gaps between polymer, whereas for 3D printing strips, no applied pressure was required. The figure here illustrates the 3D printed strips where the weight percentage are in terms of Pounamu, which is 10 weight percent, 7.5, 5, and 0. As you can see, the color gradually darkens, increasing with jade content, but no significant differences are seen beyond that. Next, I will discuss the impact of NZJ content on the flammability of the 3D printed composites. The figure right here illustrates the flammability behavior of 3D printed PLA NZJ composites. In a 10 weight percentage of Pounamu composite, exhibited a 25% reduction in burn length compared to the 0 weight percent containing no Pounamu inside. Even though the 10 weight percent sample showed a statistically significant decrease compared to the 0 and 5 weighted percented composites, there is a gradual decrease observed with increasing NZJ content. This result is expected since a higher NZJ content results in less material available to burn within the given sample dimensions. As for figure B, an increase in jade content did not lead to a statistically significant decrease in the linear burning rate due to the relatively high standard deviation in the flame time measurements. However, a gradual decrease can be seen, and the 10 weighted percentage composite exhibited a 30% reduction in the burning rate compared to the neat PLA. There would be options out there to enhance flame retardancy if that was required for the intended application, such as applying talc in the composite. So let's talk about the thermodecomposition. In figure A, the mass of neat PLA decreases at higher temperatures compared to NZ jade compounded PLAs. The differences among the jade compounded PLAs are insignificant, with most of the evaporation completing around 365 degrees, while neat PLA completes at approximately 370 degrees. Figure B here demonstrates that the thermodecomposition of jade compounded PLA initiates and concludes at a lower temperature, approximately 5 degrees lower than neat PLA. Compounding NZ jade leads to a reduction in thermal stability regardless of the composition. It is possible to hypothesize that the compounded NZJ particles provided reactive sites for degradation. Nonetheless, the exact cause of this trend is unknown. Next, we will talk about the partial degradation. We employ rheometry to complete the kinetics of molecular weight decrease due to thermodynamic degradation for each composite, which is shown in the top figure. To quantitatively compare the degradation kinetics, a fitting constant with a physical meaning of half time is used where decreasing half of the complex viscosity is present in the bottom figure. While there is no significant difference between the 0 and 5 weighted percentages composites, a discernible trend of decreasing half time with increasing NZJ content can be seen. Hence, it is reasonable to expect that the thermodegradation can be further accelerated by incorporating higher amounts of New Zealand jade in the composite. It is known that biodegradation can also occur more rapidly on shorter polymer chains of PLA. Hence, the composite containing New Zealand jade, which undergo faster thermodegradation and generate short polymer molecules, may experience accelerated biodegradation compared to neat PLA. However, in this research, it was out of the scope, so future research would be required to investigate the effect of New Zealand jade compounding on the biodegradation of such composite. I will now discuss about the determined tensile properties on the next slide. The tensile tests conducted provided insights into the mechanical properties of the composites, including stiffness, strength, ductility, and toughness, which are crucial for assessing their performance under linear stretching conditions and suitability for specific applications. These tests aim to investigate how to add the NZ jade and the preparation processes, which is 3D printing versus compression molding, influences the mechanical performance of the composite. The figure here demonstrates that the Young modulus, which indicates the stiffness of the material, increases with the J content for compression molded strips, while the Young's modulus remains the same for the 3D printed strips. Such results highlight the different mechanical behavior of composites depending on the presence of NZ jade and the preparation process. 3D printing leads to softer and more ductile composites due to process induces thermal oxidative degradation of the polymer, leading to a decrease in molecular weight, while compression molding results in stiffer but more brittle composites, which are reflected by the ultimate tensile strain, toughness, and tensile strength results. Overall, the addition of NZ jade affects the mechanical properties differently in two processes with varying levels of significance. Next, I will talk about the 3-point bending properties determined. The 3-point bending tests were conducted to evaluate the mechanical properties of the composites under bending conditions. So similar to tensile tests, but these evaluate the material performance in bending applications. The test reveals that the addition of NZ jade affects the flexural modulus and the strength of the composite shown in A and B figures, respectively, with the effects of being more pronounced in the 3D printed strips than in compression molded strips. The presence of the defects and reduced molecular weight in 3D printed composites contribute to lower flexural strength shown in figure B. The ultimate flexural strain shown in figure C decreases with increased J content, indicating reduced ductility in the composites. These findings highlight the importance of considering the process conditions and material properties when utilizing 3D printing for biodegradable plastics, as they may be more susceptible to thermal degradation and exhibit altered mechanical performance compared to compression molded counterparts. So to conclude, the addition of NZJ particles in PLA NZJ composite increases flame retardation, which means reduced flammability, accelerates thermal degradation, and improves mechanical properties with increasing J content. Lastly, I would like to thank everyone that has supported us for this research. Thank you for listening. Any questions? Excuse me, sir, are you still here? If there's no questions, I'm going to unshare this slide.
Hello, thank you very much, Lilian, for your presentation. I'm very sorry for the inconvenience. So, any questions?
That is no problem, by the way.
Okay. I hope there are no questions. So, we are moving on to next presentation by Armand W. Kone from Nangu Agrawal University, Cote d'Ivoire. Can you please share your screen, Dr. Armand? Hello, Armand. Can you please share the screen? Okay, the slides are visible and you can start your presentation. Hello, Dr. Arman. Your slides are visible. Please start your presentation. Your voice is not audible. We cannot hear your voice. ఏడున్నాడు? I think Dr. Arman Kone is having some audio problem. We will call him and we will guide him. Meanwhile, we'll have presentation from Professor A.J. Jin from Ningbo University, China. The presentation title is Theoretical Model and Simulation of the Power Utility Matrix in order to achieve carbon peak and carbon neutrality. Professor Jin, can you please share the screen? You need to unmute.
Hello, everyone. And Sarah, am I getting across with the voice? Is my
Yes,
voice on? Okay.
yes, your voice is on and the slides are visible.
Okay. Good morning or good afternoon, worldwide, wherever you are. And my presentation is up on the carbon neutrality about models and simulations of the smart power utility matrix. I'm glad to see new friends. There may be some old friends over the decade before. And so I will be going through my self-introduction bio. I'm a professor in Ningbo University, China. Previously, I was in University of Minnesota. I see an alum in the previous talk. Currently, my research area focus is on the carbon neutrality, on renewable energies, energy storage, and smart grid. previously, when I got my doctorate degree in Minnesota, I was in physics and also worked on the engineering, like in WE department over there, physics department, spent many years there. As the presentation is outlined in this page, and I'll first give you the introduction, mostly about the renewable energies. Then I took on my endeavor to set up a ubiquitous mathematical model to incorporate contribution from energy resources, energy storage, and also the grid. The aim for math model is to tackle the quality energy supply, economics, and also above all the carbon emission. This tool will provide customer control for the output, the three outputs as I outlined earlier. Then we'll go on to the case study from our research group, and I'll share with you my team as well as conclusion acknowledgements. This is a brief picture on development in renewable energies and clean technology. In this page, you can see multiple distributed energy sources as well as some interesting the new alternative energy. If I may, here is a mix of English and bilingual slide. It's about wind power, solar thermal, and the photovoltaic with the solar energy supply. I will go on to detail later on. In the bottom portion, I'm showing the geothermal, ocean thermal, as well as the clean coal, which meant already removed the carbon and the nitric and the sulfuric acid component. Here is the scientific knowledge accumulated over last couple of decades, and I contributed or authored the 4 books as editor as well as the author. And I'm not going into the detail. The title going through for you is this year I'm wrapping up the carbon neutrality drive for clean energy industry revolution. The publisher is Tsinghua University, the university publisher in China. And the prior books are published in different countries, in Germany, in US with Springer, as well as in China. This slide showing you the solar cell with different technology. Right-hand side are probably familiar to all of you. It's about the solar crystalline with single crystalline, polycrystalline, as well as the 3,5 compound, the gallium arsenide with solar cell. The thin film traditionally gives lower efficiency than what we really would like to have. As that the traditional thin film is on the lower hand corner. However, the thin film in development as emerging technology actually is doing very promising the efficiency performance, which is shown on the lower left corner. It's a perovskite, and the tandem solar cells can deliver high efficiency as good as over 30%. Now, the challenge for the emerging new solar cell is still there. Mainly, it's the lifetime. We're expecting in a couple of years, maybe lifetime can exceed more than 3 years. At that time, commercialization will be very competitive. Even though it's 3 years, less than the crystalline solar cell. Market-wise, economic, it's very effective. As a physicist, I like to share with you a couple of physics slides. This slide probably very familiar to you. This is Mr. Einstein, and he wrote a famous formula, E equal to mc squared. By the way, he did not gain Nobel Prize for that. Most famous, probably the top scientific discovery of the energy and mass relationship over there. However, there is a great discovery, one of them by Einstein at the very beginning, and that's a photovoltaic. Einstein states as the light hit the material, electrons can be excited and escape the surface. And that creates the electron hole pair, and the particular excitation will produce electricity. For this particular discovery and the formula showing on the right-hand side, lower right-hand side, if you can see my hand waving there, and the energy and frequency or wavelength of the light is set up over there. And relationship has a little difference of the surface energy, escape energy. Einstein wrote that formula, K equal to HF minus the surface energy of phi, and he won Nobel Prize for this one. We probably know less about what Einstein won this particular topic for Nobel Prize. Now, left-hand side is a very far-reaching solar on the roof, this solar energy. There's a global push for renewable energies. In China, there are, as far as I read last time, was over 100 counties has government incentive to install solar on the roof, which is very significant, and also the solar energy contribution to the total energy is increasing rapidly. Well, maybe over here I'll make a projection for solar energy. In order to achieve the carbon peaking and the carbon neutrality, planning to utilize the solar energy, the first to reach 27% for the solar peaking, and then there's 47% of solar energy we achieve the carbon neutrality. And that's a planning, hope we achieve there on time, on table. And I think we have the technology sufficient at this point already. Next is the market-wise to get commercialization success and to get good breakthroughs to achieve this goal. This particular slide I published in nature.com with scientific reports. This particular slide showing you on the left-hand side the three energy resources. So one is a renewable power on the top left, and then the energy storage on the middle on the left. And the lower left is the grid power. Our research tried to incorporate all these energy sources and have both hardware to deliver this power to output as well as software control. Namely, the software was big, smart data capable of deep learning and have good arithmetic control. As you see visually on this slide, the model we set up is also a generic with 3 input parameters on the left, and then the output parameters on the right, which meaning the quality energy output as a load, as well as the prediction, control, and trading of the carbon emission. The important factor for this big equation include the economics, and so the cost is one of the three critical outputs. Now, the beauty of this particular discovery, as according to handful, more than a hand count of reviewers, they believe this phenomenon should have been discovered, and they're very happy that our research group has achieved this discovery of the theory. Now, we would enable customers use and I'm not sure, I just received a reminder. I'll keep on going. This slide illustrates the financial performance for any published energy source, meaning the published for trading. And the power cost would be for power generation and the energy storage, as well as the cost from the grid. And by the way, there's a significant factor dictated in by energy policy, namely for different schedule, energy cost would be different. And the CP is energy input parameter for different cost scale. Here is a generic model which I love dearly, and I try to get across in a short time frame for you what this particular formula means. Left-hand side is the three critical output variables, as you have seen in the previous demonstration of graphics. Right-hand side, we have seen the three input parameters, which is generic input parameters, including the renewable energy, energy storage in the second row, and also grid power on the third row. Now, interesting part is the middle matrix. This is a characterization of a particular smart energy system, and each coefficient is really a characteristic of description how the system performs. If an engineer do the design for a power supply in distributed energy sources, this 3x3 square matrix would provide us huge knowledge, good information. From there, we would be able to output interesting planning tools, including, like Ole we said, user can key in what they would like to achieve in giving system condition. Pardon me. I have to talk, take it a little short. Yeah, skip the more information from last slide. This one is the big data, the data incorporation from the online performance survey with different energy storage. And main goal of this slide is to show how the energy output in the color coding, the prediction, how these two could match. And with different schemes of energy storage in different time zone, the scheduling power output and also the load consumption. These two have interesting interplay. The lower left-hand side, I would like to guide you to the lower left-hand side. And from this bit the figure, please just look at the dotted line. One was a blue dotted line, and the other is a red dotted line. Over there, you see they are pretty close with close to 600 megawatt hour of energy storage. Megawatt hour is about 1,000, well, 1,000 kilowatt hour. You usually pay bill by kilowatt hour in the unit of power. And so the lower left-hand side, what you see, these two are pretty close, and then utilization of energy storage would give you supply of sufficiency, as well as now incorporation of solar and the renewable energies. Our prior figure and equation gives you a generic 3x3 connection from transforming input variables to output variables. That generic can be extended. And right-hand side is one case study with dual energy storage. And dual energy storage has many interesting features, very important beneficial features. And I will highlight in next figure. Next slide showing this particular dual energy storage. And you can see in the figure, we have two batteries. One could be in charging state, the other in discharging state. And the highlight would be this one can sufficiently absorb whatever available from
Sorry for the interruption, Professor. We cannot see the slides.
You cannot. Can
No,
you see
please.
here?
Can you
Okay.
please share the screen again?
Okay, let me click on share again.
Yes, please.
Can you see now? Hello? Can
No,
you see?
no,
No.
no.
Okay. So my voice is getting across. However, the share screen, the wheel is
Yes,
turning. Wheel
you
is
can
turning.
see.
Can you see?
No,
No, there's some challenge here. Why it's not showing? Technical difficulty.
okay.
Actually, showing screen. Let me close some windows.
Okay.
Can you see? Tell me, I'll keep on trying. When you can see, tell me, okay?
Okay, actually we didn't see it.
Okay. Let me turn off. Share my screen.
Yes, share screen and open the window where your PowerPoint presentation is there.
Okay, open the window.
So
My window is open.
click on the window where your PPT is there.
Here's PPT with a window, the presentation mode, the full
Okay,
screen
yes, yes, we can see now.
mode. Okay, thank you. Let
Okay,
me pick up from the dual energy storage. Okay, this slide, I hear you about the screen. This slide particularly showing you a dual energy storage model, and the figure on the right-hand side, you see two storage. One is A, the other is B, and our prior equation, generic equation, can include this particular case. Now, this case has several benefits, and it can sufficiently absorb the renewable energies, namely to resolve, at least mitigate the discounted solar or wind or any instability in the energy supply. Moreover, the battery life due to this particular scheme can be greatly increased, can reach at least the specification. Each storage in this case can reach sufficient charging and sufficient the discharging, namely the deep cycles. Since they can reach the full cycle of charge-discharge, which is very beneficial for battery life. More schedule. This also can incorporate mobile energy storage. When one go offline, the other is still online. I'm not going into more details, simply stating this is a smart energy management system and algorithm can incorporate this power economy, the emission of this factor, the critical output factors. Well, I like to lead the audience to my team. Our team has a strong combination of various fields, several professors, and also the industry leader, like in the China Huanan Group, which is last year #1 solar installer in China, #1 of all, the top one of all the solar installation companies. Dr. Liu, he was in my group, currently over there doing his own commercialization. Graduated from Tsinghua University, in the top university of China. I'm not going to every professor, doctors, and engineers. Here's just a brief view. As a summary, we have developed a model with a 3x3 matrix. And PUM is a power utility model, which serves as a foundation for generic smart system. I just present you a universal and expandable theory that can be extended to a variety of cases. And we have set up an algorithm that drives optimal scheduling to take advantage of the economy with energy different pricing system. And that can also incorporate the deep learning in artificial intelligence. I do not have enough time to go into the energy blockchain for trading. I'll leave you the food of thought that can incorporate for the trading part. So the user interface I also mentioned for the energy supplies, trades, and carbon emission control. Moreover, we believe this particular model can set up for a great in-depth library with deep learning capability for the application of renewable energy systems. And as I touched on the complementary energy supply, complementarity of the solar and wind to take advantage of different time zones of power generation capacity. And I like to acknowledge contributions of my team. Without their support, this achievement of our research and development would be nearly impossible, next to impossible. So we welcome innovators and young talents to join in cooperation with our team. Thank you, the organizer. And let me leave in the last slide, which is the distribution for aim to achieve our carbon neutrality in the right-hand side, which states the solar power is going to be the #1 in carbon neutrality energy structure, take up 47%, and we have a long way to go, or much more marketing the commercialization for the solar energy to extend to capture the market. Thank you. Any questions? It's the time for your question.
Thank you, Professor Jean, for your presentation. It was informative, and we would like to thank all the associated agencies and institutes helping this project, and the associated faculty and the students as well. Any
Yes.
questions? I hope there are no questions. We are moving on to next presentation by Armand Kone. So, Dr. Armand, are you ready now to present your talk?
I hope
Yes, it's
thing
clear.
nice. Are you hearing me?
Yes, it's clear now.
Okay, thank you.
You can start.
Thank you. So I'm Kone Armand from the University of Nangua in Abidjan, Cote d'Ivoire. I'm going to let me okay. How to reduce this to be honest. Just a minute for me to okay. Amen. Okay. So the topic of my presentation is soil organic carbon mineralization and storage under the rising fire regime in the Guinean savanna in West Africa. So we are in a zone where rainfall is sufficient enough, is high enough to maintain or to transform, to allow transformation of the savanna into forest. But the thing is that herbivory is low. So the maintenance of the savanna ecosystem is driven by fires. This is why fire are used as a tool to control savanna and the associated biodiversity. So for decades in the region, in Cote d'Ivoire, in the central part, fire is lighted every year in the mid-dry season, that is in January. And this has been conducted for since 1962 to now. And although fire is lighted annually, this failed to prevent bush encroachment. This is why two new fire lightning period are under experimentation. That is the late fire, which is lighted in November, start of a dry season, and no, the early fire, the early fire in November at the start of the dry season, and the late fire in March, end of dry season. The objective is to evaluate to see whether this new fire lightning period can induce greater soil organic carbon sequestration and maintain soil biodiversity at levels that are better than those encountered on the plots where the usual mid-season fire is applied annually. This is a study which is complementary to the one which is focused on vegetation cover, since primarily fire is used to control vegetation cover. We know that there may be some consequence on soil functioning, primarily on soil microbial activities and soil carbon sequestration, which are important, crucial matters today in the context on climate change and climate mitigation. So the study took place in Central Cote d'Ivoire, as you can see on this slide, where savanna is the main vegetation facies, at least 80%. The 20 over percent are covered by forest. Some species from shrub species of the dominant are Pleidiostigma tonengi, Costopteris febrifuga, and Terminalia schemperiana. We can have a list of 6 dominant species, but let's focus on these 3. So the study took place at a landscape level at 3 sites distributed in the savanna, which are called Plateau, Piste du Nord, and Marigot Salé. This slide show some pictures of fire lighted at the different dates mentioned above. The first at the left side is the early fire. At the right side, the late fire, and in the middle, the mid-dry season fire. So which soil variable have we measured and at which time? We do measurement at 2 times. The first is 3 years after experimental settlement, and the second 8 years after experimental settlement. So after 3 years, we focus on soil organic carbon and nitrogen concentration in addition to pH. We also examine soil microbial attributes such as microbial biomass carbon, basal soil respiration, and beta glucosidase activity. All of these parameters or variables are linked with carbon cycle. 8 years after, measurements were done deeper in the soil till the 30 centimeter, and we once again focused on carbon, total nitrogen, and pH in terms of concentration for carbon and nitrogen. And for this occasion, we make estimation of the soil organic carbon stocks and total nitrogen stocks. As a proxy, we also sampled and measured the quantity of grass litter we could find at the soil surface. What data were yielded 3 years after settlement? We can see on this table that significant variation or significant effects were observed for basal soil respiration, which is carbon mineralization, and beta glucosidase activity, with greater value recorded in the usual mid-dry season fire. That is value recorded under the two new burning periods, early dry season and late dry season, were lower. For both parameters, we showed significant difference among burning periods. What about litter stock at the soil surface? Significant was the difference between the three type of plots, with greater value on the usual mid-dry season fire at approximately 0.7 megagram hectare. What about soil organic carbon and total soil nitrogen stock measured 8 years after? Regarding soil organic carbon stock, difference between fire burning period was observed only on the topsoil, that is 0.10 centimeter deep in the soil, with a value of approximately 2 megagram hectare recorded under the mid-dry season fire plots against approximately 17 megagram under the two new fire periods being tested. When considering the whole 13 centimeters depth, no significant difference could be observed, although there was a tendency towards greater value under the mid-dry season fire plots. What about soil total nitrogen stock? Patterns are here different, with no significant difference amongst the plots, the type of plots subjected to the different period of fire, although we can note an increasing trend from the early dry season to the late dry season in the stocks of nitrogen. So what can be the mechanism that underpin this change, particularly in terms of decrease in the soil organic carbon, basal soil respiration, and basal soil respiration and soil organic carbon stock under the two new fire time being tested. The thing is that on those plots we recorded lower litter quantity. Another study under investigation in parallel to what we are doing show that the new the plots of the new date of fire lightning harbored lower earthworm density and diversity, and we think that the conjunction of these two factors, lower litter availability, lower abundance and diversity of earthworm, may have led to the decrease in the microbial activity observed, and consequently the lower soil organic carbon stocks and the new type of plots. That is, the functioning was greater on the mid-dry season fire, which is applied since 6 decades now. What can we conclude? 8 years after starting this new experiment, any of the new two periods under investigation could be found to be more performant than the mid-dry season fire in terms of soil organic carbon cycling and storage. This finding should be taken into account in conjunction with the result obtained for the effect of this type of fire on the vegetation cover, so that an overall and more interesting management of the savanna be driver for the sustainability of these ecosystems. This is what we have to show this morning. Thank you for your attention. Thank you. Hello. Hello. Wow. Are you hearing me? I'm at the end of my presentation, Sarah.
Thank you very much, Dr. Arman, for your presentation. Any questions? You can also ask the questions in the chat box.
Okay.
Hope there are no questions. So we are moving on to the next presentation by Khushbu Dahiya from Indira Gandhi Delhi Technical University for Women, India. The presentation title is Toxicity of Fine Particulate Matter During Firework Event in Delhi, India.
Ma'am, I'm unable to share my screen.
Oh, I have made you the presenter now, just now.
Uh,
Can you please try it now?
yes, ma'am, I'm trying.
Is that Shivani who is trying to share?
Yes, ma'am.
Okay, so I made the presenter for Khushbu Dahiya, so that's the reason why you are not able to share. Please try now.
Uh, just a second, ma'am.
Okay. Yes, the slides
Is
are
it
visible.
visible, ma'am?
Yes.
A very warm greetings to all. This is Khushbu Daya, PhD scholar from IGDTU, Delhi, India. My topic for today's presentation is toxicity of a fine particulate matter during firework events in Delhi, India. Aerosols. Aerosols are particulate matter that are solids or liquid particles suspended in the atmosphere. There are two sources for it. That is, first one is the natural and the second is the anthropogenic. And from aerosols, there are following effects, that is, the climate change effect and the health effects. Aerosols can be divided into various types based on their sizes. But here we are focusing on the fine particulate matter, that are the particles with size less than 2.5 micrometer. Composition of PM2.5. It comprises of elements, carbonaceous aerosols, ionic components. Among these, carbonaceous aerosols are the toxic and the carcinogenic that causes adverse health effects. It includes PAHs, that is the polycyclic aromatic hydrocarbons, quinones, copper, iron, zinc, secondary organic aerosols. These are the redox active species that causes the oxidative potential.
Sorry for the interruption.
Yes, ma'am.
Shivani, can you please change the slides? Because we are seeing on the first slide only.
You are seeing just first slide.
Yeah,
Just
yes, you have to change every time by clicking on the
oh,
slide.
ma'am, from my side, I'm changing, but it's not visible to you.
Yeah,
I
Is it okay, ma'am,
uh,
now?
I
yes, we
think
can see the
you could
second
do the
slide.
slideshow. You
Yeah,
could make
slideshow
Uh,
it
is better.
on the slideshow. Yeah.
is it okay, ma'am, now?
Put
Yes,
it on the
but it
slideshow mode.
Uh, ma'am, slideshow is not working. Is it okay? Hello?
Yeah, slide is visible.
Okay, ma'am. Okay. Shall I continue?
I think you will
yes,
have to spell it again.
Shall I repeat once again?
yes, yes.
Okay. Aerosols are the particulate matter that are solid or liquid particles suspended in the atmosphere. Aerosols have two sources. First one is the natural and the second is the anthropogenic. And these aerosols causes the following effects, that is the climate change effect and the health effects. Aerosols are divided into various types based on their particle sizes. But here we are going to focus on the fine particulate matter that have particle size less than 2.5 micrometer. Now the chemical composition of PM2.5. It comprises of elements, carbonaceous aerosols, ionic compounds. Among these, carbonaceous aerosols are the toxic and the carcinogenic that causes adverse health effects. It includes PAHs, that is the polycyclic aromatic hydrocarbons, quinones, copper, iron, zinc, secondary organic aerosols. These are the redox active species that mainly leads to oxidative potential. Objectives. The first objective is to study the effect of firework events activities during Diwali festival on concentration of a PM2.5 in Delhi. Second is to investigate the toxicity of a PM2.5 in terms of oxidative potential during firework events in Delhi, India. Here, the sampling site was conducted at Indira Gandhi Delhi Technical University for Women, India. The sampler was located 6 meters above the ground level and the university campus was 400 meters away from interstate bus terminal Kashmiri Gate that generally caters to the traffic congestion. And the sampling period was 15th October 2018 to 26th November 2018, and in this year Diwali was observed on 7th of November. What actually oxidative potential is? It is the ability of a PM2.5 chemical constituents to produce the reactive oxygen species ROS in the respiratory system by catalyzing the transfer of electrons from the reducing agents to oxygen to produce the superoxides and peroxides. It is generally studied by dithiotrytiol assay, that is the DTT assay, which can be evaluated in two ways, that is the extrinsic oxidative potential, that is the volume normalized, and the intrinsic oxidative potential, that is the mass normalized. And the redox active species constitutes of PM2.5, that is the water soluble organic carbon and the water insoluble organic carbon, metals and secondary organic aerosols. This is the methodology that we have followed at the time of a sampling, and the PM2.5 concentration was measured using this formula. Here is the details of a DTT assay that we have followed. PM2.5 contains the redox active species such as metals and organic compounds that induces oxidative stress, and redox active species when inhaled generate redox imbalance and produces reactive oxygen species. The DTT accepts electron from the reactive oxygen species from the PM2.5 and forms DTT acts as a reducing agent that reacts with the redox active species in PM2.5, mimicking their reaction with the antioxidants in the body. Here are some of the mechanisms that are followed in DTT assay. When DTT reacts with oxidizing species in PM2.5, the thiol groups in DTT are oxidized to form disulfide bonds, resulting in this structure. The DTT structures we have mentioned here, as you can all see, and the DTNB reacts with the remaining thiol groups in DTT to form DTNB reacts with the thiol groups in DTT, it is reduced. The reduction leads to formation of a 2-nitro 5-thiobenzoic acid, that is a TNB yellow color compound, and the yellow color compound was then spectrophotometrically at a specific wavelength of 412 was analyzed using the UV spectrophotometer. Measuring of oxidative potential of PM2.5. We have used acellular DTT assay for analysis of oxidative potential, and the calibration curve was plotted, and from this the DTT consumption rate was calculated using the formula, that is the extrinsic oxidative potential volume normalized and the intrinsic oxidative potential mass normalized using the above formulas. Now here are the basic steps that was followed. First one was a stock preparation. Second was the calibration curve. We have obtained this calibration curve with R square value of 0.96, and this equation was later used for the calculation of a DTT consumption rate. Third is the DTT consumption rate calculation. We'll be discussing in detail the DTT consumption rate calculation in upcoming slides. Experimental DTT assay. The first step was the PM2.5 is extracted from the filter paper using methanol and deionized water using ultrasonicator, and the sample is combined with the buffer in acid washed vials, and the solution is heated at 37 degrees Celsius, as you all can see. UV visible analysis. The DTT reacts with the DTNB to form a yellow colored compound, that is TNB, and was spectrophotochemically was analyzed using the UV spectrophotometer at 412 nanometer. Here are the results that we have obtained from our experiment. First is the daily variation of a PM2.5 concentration. As you can all see that the PM2.5 concentration is seen to be highest among all the samples at Diwali night. And the data we have obtained is that the average pre-Diwali PM 2.5 concentration was 112.1 microgram per meter cube, and Diwali day it was 115 microgram per meter cube. On Diwali night, it was the highest, that is the 1426.33 microgram per meter cube, and average post Diwali was 249.8 microgram per meter cube. And in this highest concentration of a PM 2.5 was also seen because of the emission of metals that have already been reported by Shivani et al. In 2018, that are the main emissions of the fireworks on Diwali night. In other samples also, the little bit elevation was seen in a PM 2.5 concentration. That might be because of the vehicular exhaust, industrial emission, and burning biomass. Second we have is the DTT consumption rate. We have plotted the DTT consumption rate for all the samples, and the equation this that we have obtained from the calibration curve was used to calculate the DTT consumption rate. And we can see that for graph for the Diwali was known to have the highest consumption rate, that is the 9.4302, which is the highest consumption rate. That clearly depicts that there was a highest redox active species that was present in a PM 2.5 at Diwali night. And similar graphs we have plotted for each and every samples, and in most of the samples we have R square value, that is 0.98 and 0.99. Now we have plotted the DTT consumption rate versus day. Here we can see that the DTT consumption rate was highest for the Diwali night, sorry. Here we have is the extrinsic DTT, that is volume normalized oxidative potential, and intrinsic DTT mass normalized oxidative potential. We have plotted these volume normalized oxidative potential and mass normalized oxidative potential against day, and the bar chart represents the DTT volume normalized oxidative potential, and the secondary axis represents the mass normalized DTT oxidative potential. As we can see that DTT mass normalized, there is no significant change is observed in Diwali day and Diwali night samples. And for if we see that the DTT volume normalized oxidative potential, large significant increase is seen in this volume normalized DTT values. It is quite comparable with the DTT consumption rate that we have seen in earlier slides. So we can conclude that from this that volume normalized oxidative potential is a correct or the much more accurate indicator of the toxicity of a PM 2.5 as compared to the mass normalized DTT oxidative potential. So here are the values which we have evaluated from the formulas. This is the DTT volume normalized oxidative potential for pre-Diwali, Diwali, and post-Diwali. And here is the as you can see that there is not much change is observed in the mass normalized value, and there is a significant increase is seen in Diwali day and night. Now we conclude as we have seen that 24 hours average PM 2.5 concentration of a pre-Diwali and post-Diwali days were 112.1 microgram per meter cube, and for the post-Diwali it was 249.8 microgram per meter cube respectively. And it was seen that on Diwali night the PM 2.5 concentration was a nearly 10 times higher, that is the 1426.3 microgram per meter cube than daytime concentration. And we can see that during the Diwali festival, the PM2.5 concentration has exceeded the national ambient air quality standard, that is the permissible limit, which is the 60 microgram per meter cube, by more than 12 times, which revealed the sustainable impact of firecrackers on the air quality. And the DTT consumption rate during the Diwali night was almost 11 times higher than the Diwali day, which confirmed that there is an enhanced toxicity of a PM2.5. And it is also observed that the highest oxidative potential volume normalized DTT and minimum oxidative potential mass normalized DTT during Diwali event was observed. And it can also be concluded that the volume normalized oxidative potential is a better indicator of a toxicity in comparison to the mass normalized oxidative potential. The study highlights that the air quality measurement should include the oxidative potential along with the PM2.5 mass concentration to consider the associated health impacts due to toxic potential. This presentation outlines the urgency to curb firework pollution in India, especially in Delhi, due to direct health implications of a PM2.5 exposure. Awareness, education, and strict regulations on a firework manufacturing and consumption are crucial. Here are the references. Thank you so much. Any questions?
Thank you, Shivani, for your presentation. Any questions? I hope there are no questions. So we'll have a presentation from Ravi Ande from University College of Science, Usmania University, India. The presentation title is Design of Objective Function Based Segmentation Technique and Supervised Classification Scheme for Remote Sensing Images. You can start the presentation, Dr. Ravi.
Ma'am, it is not showing my screen.
Hello?
Ma'am. Yeah, when I went my Windows,
Okay.
uh, uh, just wait, ma'am. Wait, wait.
Okay.
No, 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 no. Sorry. And when I sharing, it's always showing my email, not uh, screening.
Okay. Can you please rejoin again?
Ah,
Dr. Ravi, I have made you the presenter. Can you please try now? Dr. Ravi, I have made you the presenter. Can you please try it now? Yes, the slides are visible.
Mm,
Open your PPT, Dr. Ravi, and click on the share screen.
um,
Select select the window
uh,
where the PowerPoint is there.
yes, yes, ma'am. I got now, just now.
Okay.
Thank you. Yeah, okay. Sorry for the inconvenience.
Okay.
Yeah,
Can you try it?
yeah, ma'am. Is it visible, ma'am?
No, we can see your Gmail.
Sorry. Wait.
Click on stop sharing and again try to share the PPT.
Um,
It's visible now.
this one, ma'am. Okay.
Yes. You
Okay.
can start.
Yeah, this is the topic design of objective function based segmentation technique and supervised classification scheme for remote sensing images. Uh, the Actually this topic is the remote comes under the remote sensing, which is the part of in the environmental science also. The adding by we have taken by adding the artificial intelligence and machine learning techniques in the various images of the earth materials. So, in introduction, image segmentation is a fundamental step of for meaningful analyzing and interpretation of an image. It is considered as a mandatory processing step for the extracting objects from their backgrounds in many computer vision oriented applications. The goals of segmentation carried the concept that the image orient region should contain similar types of homogeneous pixel with respect to some common features like color intensity and texture, so that it can be analyzed easily. So to be more precise, using segmentation, a label is assigned to every pixel of an image so that pixel which carry the same label can contain specific characteristics. So I took that image techniques. So whatever the chosen the area of the my primary area of the remote sensing by sort out that remote sensing area in that area, sort out the mineral exploration minerals, some minerals like magnetic. I carried out in that area like resistivity, gravity, and magnetic are various geophysical instrumentation surveys. After that, I decided to go for the segmentation techniques. The segmentation techniques will the useful to the physical features to find out the color, texture, tone, and drainage pattern even using useful in the uh, groundwater level prediction by using the um, artificial neural network on imagery processing units, and even to find out the uh, hydrocarbons, the petroleum or oil resources by using the um, multi-layer background of the neural network. Also, I used to find out the hydrocarbon deposits and even sulfur deposits. Also, I find out in that area to carry it out by using the artificial intelligence techniques. So the segmentation techniques are more useful by using the even statistical techniques, the common statistical techniques of the in the like geostatistical estimations. The histogram based methods or edge detective methods or graph partitioning methods have been taken in my area. So clustering methods also, I decided to take the clustering methods to supervised classification of the mineral deposits. Like the data based on the data, I took that data and even the geospatial data and geostatistical data I used to carried out. I used to sort out that mineral deposits to using the based methods. Histogram based methods also very efficient compared to their image segmentation method because they typically require only one pass through the pixels. In this technique, a histogram is computed for all of the pixel in the image. So pixels are very the minute pixels are very the minute imageries. We have to carry out the various imageries from that pixels. So the peak and valley in the histogram are used to locate clusters in the image. The color or intensity can be used as the measurement of the histogram. So color based on the color composition of the intensity will give uh, the anomaly of the histogram. So the refinement of this technique is to recursively apply the histogram seeks method to clusters in the image order to divide them as a small clusters. So when I taken the area is based on the image processing, I divided as the clusters. So based on the cluster, in one cluster, we have to divide the small clusterings. And based on the clusterings, we have to sort out that deposits. So the edge detection method also and is also developed field and it's own within the image process. The region also, the boundaries and the edge are closely related since there is often a sharp change in intensity at the region boundaries. So based on the edge methods, we have to detect the boundaries. The detect the boundaries, but based on the boundaries, we have to connect that the nearest clustering units and graph partitioning methods. The graph partitioning methods also it is the tool of image segmentation. Their model in the impact of pixel neighborhoods. So when the pixels are near clustering methods in the one area of the cluster, we have to take that we have to decide that cluster and sort out that what are the pixels are located in that area. So in this method, the image is modeled as a weighted undirected graph. The usually a pixel or a group of pixels are associated with nodes or edge weights define the similarly between the neighborhood pixels. So we are deciding to pixels and connecting the neighborhood pixels also. So that we could find out the what are the divides are uh, more valuable, more accuracy. So objective of the research. The following the objective of the research: developing a new objective function for image segmentation. The developing an efficient and accurate optimization algorithms for segmenting images, developing a quantum mechanics based algorithms for segmenting especially color image with higher segmentation accuracy, developing a hybrid image classification techniques like hyperspectrometers, like we are using in the remote sensing, like multi resolution remote sensing satellite imagery also. So the hyper spectral imaging. So it is the imaging which is the Earth satellites, Earth observatory satellite imaging the Earth materials, which is uh, the radar satellite even uh, we are using for the Earth materials, the surface methods like various deposits for finding the deposits are based on the electromagnetic reflectance curves. So we are taken that the pixel containing the sampling spectrum that used to identify the materials. What are the materials are present in the pixel according to the reflectancy curve based on the images, the swath, width and length of the um, curves and length of the swath. We can identify the reflectance curve based on the wavelength. Is it shallow wave, or infrared waves based on the mineral deposits? The uh, shallow infrared waves also we are using the water and the green color wavelength and vegetation. The infrared like visible colors are presenting in that. Uh, Based on that wavelength, we will decide that mineral deposits are sort out in the pixel imageries. Then we can segment out that imageries. So the real world and GIS, Geographical Information System world models, design on the modeling techniques based on the based on the algorithms and optimization techniques. We designed this imageries, the imagery of the earth material, like that real world. We are connecting with the elevation and imagery of the graphs by even ArcGIS and uh, by using the various software methods, even Python and MATLAB also, we are using to develop that such a models, the transportation and addressing that boundaries, the water features or some survey of the controlling where the surveillance are located. What are the sampling points we are collected area? Also, we can observe the based on the model. So the flowchart for the multi scale segmentation method used on the minimum spanning tree and minimum heterogeneity rules of algorithm. I used to this too. The remote sensing imagery, the based on the imagery, we have taken the graph, the uh, graph we have taken, and we are connected with the ascending order of the edge weights, and then connecting of the imagery of the from that pixel imageries, we are uh, connecting to various deposits like merging of the components like various color composition. Based on the color composition, the initial segmentation results are connecting with the set of the parameters with minimum heterogeneity rule of the algorithms. So computing the all that based on the two methods like minimum spanning tree and minimum heterogeneity rules algorithms we are using and connecting to the computer, and based on the computer uh, supervised computer um, techniques and even deep learning techniques we are using to find out the mineral deposits, uh, and segmenting out that the secondary, the segmentation merging out that based on the color. Then we are connecting with the different scaled even materials. Even it is the basic sort of tree also. The algorithm anomaly, based on the algorithm anomaly we are deciding to the the location of the pixel or deposits to sort out based on the color composition, and finally we are deciding the useful deposits. So initial segmentation based on the uh, minimum stressing that tree also we are using, the minimum spanning tree also we are using, and to sort out the pixel, the imagery of the area of the we are taken grid point of that area to giving the going for the survey we have to divide as a um, grid point based on the base map, to take the base map and divide the grid point, and based on the grid point we are divided as a uh, uh, divided as a one area as a pixel, based on the pixel color composition sort out the various deposits, and um, Euclidean distance between the two colors, the nearest distance are we are connecting the based on the graph imageries. So based on the graph imageries we are connecting, and it will the connecting points which will give the Euclidean distance will give the anomaly after connecting the 2 points, and we are sort outing the area. What are the deposits? The based on the color composition, is it the like it is showing like a gosans? It's called gosans, like which is the outcrops of the deposits. Even the parallel segmentation based on the MPI, the master node, we prepared that data partition as a area of the taken, where grid point, we divided as a grid point of that area based on the topographical sheet members, which is available in the Survey of India. So we are sending into the as a dividing as the blocks or slave the nodes. We are taking the noding points to the every 3 nodes. We are changing that, and reverse searching forward processing. It is also called reverse searching forward processing chain. The strategy to boost the segmentation speed on a cluster platform using MPI parallel technology. So we are using as a slave nodes, we are connecting with the different blocks. For every 3 blocks, we are connecting, and finally, we are what are the data are collected, and we are connecting the nodes, the nearest nodes. Then it will indicate the different anomaly of the zone. It will give the particular mineral deposits or anomaly. So reverse searching forward processing chain based on MPI. So the source of the process also we are following to connect the step by step by using the different methods. So reverse searching forward processing also called series of steps. So series of steps we are following up to the n node, and resulting of the node n minus one. After that, we are going for the back to the step of the n node, and step and identification one, and identification two step, and one step, and source of the point up to the source of the point. Again, we are finding the different nodes, based on the nodes. We are finding the based on the color composition, finding the device. So extended buffer strategy. Extended buffer strategy also, we are blocking the normal blocks. So extending the block is a normal block. We are deciding and giving the input to the processing. of the mission, and so it will give the output of the normal block or any anomaly. So the buffer also it is extended. It is considered to be obtained a extended block. So the extended block also it will give the normal size. So based on the deposit. So it is the remove the boundary. So boundary when the various boundaries we are facing the so many boundaries in the we are decided to the mineral deposits are located in the large area. So we are divided as a two blocks in that area, and from there are so many boundaries. We are finding the six boundaries. So when the boundaries are located, we are removing the boundaries. So the boundaries of that the vectorized segmentation we are using. So the resulting by means of features neighboring objects. So connecting the we are removing the boundaries and connecting the objectives. More so after connecting the objectives, it is become a the three blocks in that area. So merging the three blocks and calculating by the using by the statistical methods. So fan sharpening techniques. Fan sharpening techniques also using to find out the imageries based on the imageries we are finding the mineral deposits and especially uh, the morphological area, which is the soils and different soils and terrain conditions and mineral deposits, what are the soils are located in that area. We could identify by using the pan sharpening techniques also. So convolutional convolutional neural network based image segmentation system. So it is the convolutional neural network based image segmentation. So data set preparation and then preparation, the model building. So based on this convolutional neural network, so data augmentation, so preparing the manual annotation, the erosional processing, and we are making the pixel imageries, even the raw imagery and the structure of the elements imagery. We have taken the various imagery process and based on this mask preparation means identification of the particular uh, area of the deposits or deposits by using connecting with the model techniques, and this model techniques will give the particular area of the mineral deposits. So, and supervised classification. Supervised classification also labeled the data within that area, which are selected the area by giving the various features in that area, uh, and based on that area, we are following that clustering algorithms, the clouds, even that spectral measurements of the remote sensing, that measuring of the deposits, measuring of the satellite imageries were sort out the deposits and measuring the color compositions also. Even the unsupervised classification, the spectral classification, which is the based on the clusters or which are unclassified, which are unlabeled data, we are divided and the various clusters based on the color composition and the segmentation results for the airborne uh, through ortho image. So our airborne techniques also we are used to find out the mineral deposits. The airborne techniques by uh, using by find out the ground truth levels, the building the trees the are blue color, are groceries are like what are the soil especially uh, the what are the colored soils? Is it the black soils or red soils or what are the colors? Yellow color. The based on this, we are connecting the composite with the A, the segmentation of the A area A and B. We are connecting with these two areas. They both are opposite, and these areas are especially the near to the blue color and yellow color also here observing in the imageries. So based on these imageries, we are connecting this ground truth level and sort out the pixels, and based on the imageries segmentation, we are deciding the what are the depots are located. The segmentation of results the specimen AISA equal to image. We are using the ground truth levels of yellow outlines of the colors. So the buildings of the area highly detected segment found in the A compared with the B area. So the highly segmented area is found in the area. So it is the located of the various mineral deposits, and even segmentation results world view two images of the area highly segmented in the area A compared with the B. So comparison of these two area, we are finding the which area is better for the exploration. The segmentation results radar charts, even radar charts also to using further to sort out the image segment of that area, particular area. What are the deposits? Is it uranium deposits or thorium or sulfur deposits? So mineral segmented out by using the deep learning. The deep learning also using to color various compositions to sort out the accuracy in that mineral recognition based on the deep techniques based on the color composition. The higher accuracy, the which is the deep colored one is the magnetite or pyrite deposits or the magnesium deposits. What are the deposits are located? The background also in the matrix is the segmentation of the black area during the mineral identification. The transmitted light image, the represent which represents the opaque mineral portion. See, the even the opaque minerals also the various the associated minerals also we are observing in this area. The which is the deeper color is the some more deposits, and values of metrics for different sensors using the two segmentation methods described in the section. So we are observing that anomalies curves, the airborne image segmentation, the specimen AISA Eagle 2 image segmentation, the worldview 2 image segmentation, radar sat 2 image segmentation. The which is the positive anomaly or a negative anomaly, which is the positive anomaly will give the accuracy of the ore body or mineral deposits. The which is the negative anomaly. The negative anomaly is the finding the difficult of the ore deposits. So speed evaluation of parallel segmentation. So in the speed evaluation parallel segmentation, which is the parameters are measuring the running time, speed up, the efficiency, effectiveness of uh, the local depots. The based on the segmentation, we have sort out these curves to find out that uh, parallel segmentation. And conclusion, there has been little comprehensive identification of transmitted light images and reflected light images of mineral in the research of intelligent mineral identification. So there are minerals how the color composition it is showing the based on the color composition, the segmentation we sort out that various deposits like uranium deposits or sulfur deposits in my research area. So a composite data set of photographs, transmitted light, and reflected light under a polarizing microscope were built in the investigation. In the identification, finding the same mineral is denoted by the some solid color block and computation of mineral particles. So in that we find out that various strategic minerals, various minerals like uranium, thorium, and even magnesium deposits also based on the imagery techniques. And this is the imagery techniques and mostly useful to find out the deposits and geological features and geophysical techniques also by using the machine learning. Uh, Thank you, ma'am. Thank you for giving this opportunity.
Thank you, Dr. Ravi, and for your presentation. Any questions? I hope there are no questions. Thank you, Dr. Ravi, for your presentation. So we are moving on to the next
Thank you.
present. Okay. So we are moving on to next oral presentation by Nwafi Gie Adi from Akobaider, Cameroon. The presentation title is Impacts of Climate Change to African Indigenous Communities and Examples of Adaptation Responses. Case of the Bakas and Bantus people living at the periphery of the Ja Biosphere Reserve.
Hello, good morning, everyone. Good afternoon.
Yes, good afternoon. Can you share the screen?
Okay, I'm right there. Let me try. Okay. Okay, can you see? Is it okay? Hello?
Yes, it's okay.
Okay, once again, good afternoon, everyone. Thank you, Sarah, for all the efforts put in to organize this sixth International Conference on Environment, Sustainability, and Climate Change. And I also very happy for the aspect of recycling and waste management that was added into the program. Thank you very much. My presentation is, as already is titled, The Impacts of Climate Change to African Indigenous Communities and Examples of Adaptation Responses. And the case in which we had to look into is the case of the Bakas and the Bantu people who are living at the periphery of the Ja Biosphere Reserve. Here, we should note that we have indigenous people, indigenous communities, that live around the Ja Reserve. And the Ja Reserve is a protected area which is already classified, under the UNESCO, the list. That's is a World Heritage of the UNESCO World Heritage. So that's the Ja Reserve. Just a brief rundown of our plan or presentation. We have the background, we have introduction, the context, and we are going to also look at the objective of this study. I'm also going to look at the methods, then I'll proceed with impacts of climate change. We are going to continue with some adaptation strategies in response of climate change. We'll look at also the results, then we will conclude with the conclusions. What are the results and what are the conclusions that we got from our study? Now, with regards to the context of our introduction, we have three questions here. We have three questions. The first issue here is to understand, is climate change a problem? The second question is, how can we stop climate change? And the third one is, what impact is climate change having on the world? So we see in our study, we had to understand that climate change is already impacting Africa disproportionately. and will continue to do so, and primarily by affecting the sectors that are key to the livelihood of vulnerable communities, such as agriculture, forestry, and fisheries. In addition to bearing the brunt of climate change and other environmental degradation challenges, Africa is often underrepresented in global climate change mitigation and adaptation efforts across multiple dimensions, for research and development, to policy and advocacy, to the ground implementation. Globally, there are estimated 370 million indigenous people whose livelihood are being negatively affected by climate change by the means of increased frequency and the intensity of extreme weather events such as droughts, flood, storms. We also have cyclones as well as heat waves, among others. Now, what's the objective of the study? Our objective here is to understand the strategies that are derived from indigenous local knowledge that indigenous groups use to deal with ecological uncertainty, which we also refer as environmental risk, such as drought, flood insecurity, and loss or displacement from land, and how they build resilience against climate related stresses and shocks. So here we are going to also see how the local population or the indigenous community they face this stress and the shocks and how they build their resilience towards climate change. Looking at our methods that we used, we have three methods here. The first method was data were collected from the field survey through focus group discussions with local communities. The second step was we collected data from 200 women actively involved in agriculture and non-timber forest products collection. And we also have 150 men who are mainly cocoa farmers. And thirdly, data were analyzed using the regression analysis approach. So here we see that forest and agriculture hold more than 30% of the climate crisis solution. And but they receive just 3% of climate finance. So these are data which we got also from further research. What are then the impacts of climate change on indigenous communities? We came out with some negative impacts, which include diseases associated with increasing temperatures, such as vector-borne and water-borne diseases, drought and desertification leading to forest fires and the loss of forest, that's forest vegetation, excessive rainfall resulting in the damage of grassland, seedlings, and other crops, rising of rivers and sea levels due to higher temperatures causing floods and erosion, which affects the livelihood of these communities. And lastly, but not the least, we have increase of new types of insects and lengthened lifespans of endemic insects that affect food insecurity and coastal erosion. We also had to look into adaptation strategies in response to these climate changes. To begin with, we see that adaptation to climate change involves changes in agricultural management practices in response to changes in climate conditions. And the common agricultural adaptation strategies used by farmers were the use of drought-resistant varieties of crops. Secondly, we also looked at crop diversification, changes in cropping pattern, and calendar of planting. Thirdly, we have forest landscape restoration through tree planting. We also have conserving soil moisture through appropriate tillage methods. And lastly, but not the least, we have improving irrigation efficiency and agroforestry. So all of these are the different adaptation methods which the indigenous people use. As you can see from the photo, here we have some community led young youth people who were planting trees, and they have engaged. They are into community engagement as far as tree planting is concerned. So that's the picture from the field. The next slide, we had to look at the situation concerning the next slide here, we had to look at the situation concerning climate change adaptation and the opportunities for capitalization. What are the opportunities that we have as far as climate change adaptation is concerned? We have four main aspects. We have this model, the model of climate preparedness and adaptation strategy. That's a model which we had to study. And amongst that, we have, as you can see, we have resilient species and ecosystems. We also have safe and healthy communities. We have foundations for success. Then we have climate ready economy and infrastructure. So here it's simply saying that for us to better prepare for adaptation strategy, we need to look into, or we need to consider having resilient species and ecosystems. That's very important. And I think we look at the next slide again. Three aspects are being addressed in this climate adaptation model. The first one is adaptation and resilience building, which remains a priority as the continent prioritizes adaptation over mitigation. But there are huge potential gains in the continent which pushes adaptation and unlocks mitigation potential in general. The second one, we have the need for capacity building in climate adaptation, and resilience remains huge. As noted in February 2020 African Union meeting that reviewed the implementation of the Malabo Declaration, such as capacity gaps and evident at national, regional, and continental levels. The last point, with the African population expected to reach 2.4 billion by 2050 and relying on a predominantly rain-fed agricultural system, critical work must be undertaken to ensure that the continent can be food secure. So these are already indicators that help us to take necessary measures in order to address the issue of climate change, because the increasing population will also have an effect on the agricultural system, and we must address this issue by carrying out critical work concerning food security. This brings us to the question of climate solutions. What are the climate solutions that we need to address here for the future? We have to merge together climate mitigation and climate adaptation. Both have to go together. Taking into account climate mitigation and putting aside climate adaptation has always been the approach which was used. But based on our research, we are proposing putting together climate mitigation and climate adaptation, which is a way forward for the future climate. And in the second model which you see, we see climate solution. We have 3 points, major points here. We need to restore, we have to manage, and we need to protect. Concerning restoration, we have to restore forest vegetation. We also have to restore wetlands. Looking at management, we have to manage timberlands. We also have to manage grazing lands. We also have to manage croplands. These are the three aspects concerning management. And looking at protection, we need to protect forest. We have to protect grassland. Then we need to protect the wetlands. So if we combine all of this, we are sure of having the climate solutions which is needed for our future climate. Looking at our model, we now have to address the issue of climate operational plan. If we have to have a way forward for climate adaptation strategy, we need a climate operational plan. And the question here is, how do we go about it? In our research, we came to understand that climate adaptation strategy needs a suitable climate change operational plan and biodiversity plan. So you see from our model, we have this merge circle. We have climate change operational plan and we have the biodiversity operational plan, which both of them must be put together. And on the right, we have the model. We see here that climate adaptation action must have 5 components. The first one is to sustain. The climate adaptation action must sustain. It must be sustainable. The second issue is that there must be engagement. We must have engagement of stakeholders, be it community engagement, be it other stakeholder engagement. We must have engagement of the different parties. It must be understood. We need to understand where we are going to in our actions for climate adaptation. Then we have to plan. Once we plan, then the last issue will now be implementation. If we have already a good plan, we will then have to implement what has been planned for climate change adaptation. That takes us to the next slide, which will address the benefits of climate change action. We have the benefits of climate action, which are environmental, economic, and social. These are the 3 benefits that we could come out with in our study. We know we benefit from environmental issues. We also benefit economically, and we have the social aspects that take into account the human beings. As you can see in the picture, we are gradually addressing gender issues relating to climate change. For us to address the adaptation responses to climate change, we need to recognize the efforts and the role played by women and gender in climate adaptation strategies. And in our study, we see here that the key role of traditional knowledge to overcome climate change is very important. Generally, the vital contribution of indigenous women was of interest in this study. Just to give a brief rundown, there is a gap for women between the rights enshrined in the law and the exercise of those rights in real life. And in our African culture, we see that for indigenous women, this gap is even greater due to the multiple forms of discrimination based on their gender, the ethnicity, and socioeconomic situation. Women suffer discrimination from within their own communities and from external rural and urban areas. The loss of traditional occupation, combined with climate change and the resulting degradation of agricultural land and natural resources, are major factors behind indigenous men's migration for outside opportunities for wage labor. So here it's simply saying that men have always migrated from the rural areas to the urban areas in search of better jobs, and thereby abandoning the women in the rural areas, who have tended to be the main actors when it comes to contributing to climate change adaptations. As you can see from the picture on the field, we see here women back way in the rural communities who are actively involved in climate adaptation strategies, as you can see. So, there's a growing number of indigenous women assuming greater responsibility for the management and governance of community lands. Therefore, it is the utmost importance to ensure the inclusion, legal recognition and meaningful participation of indigenous women in land ownership and governance at all levels. So here we are simply saying that women must be recognized. The efforts put in place by women must be recognized legally, and their participation must also be recognized by the government as far as governance is concerned. What were the results that we got? Results and conclusion. We can say here that indigenous communities have been constantly adapting to the effects of environmental stresses over a very long period, with numerous climate change adaptation mechanisms being adopted in recent decades. There are examples that show that indigenous people knowledge is one important component to the success of policies that aims to increase adaptation. You see from the picture a woman in a grazing in her agricultural plantation, and here we are still emphasizing the importance of gender as far as climate change adaptation strategies are concerned. It is with this note that I have come to the end of this presentation. Thank you very much for your attention, and I am open to any questions which are available, or the presentation will equally be shared for those who be interested to get my email and for further questions. Thank you very much for your kind attention. Thank you. Hello. Hello, Sarah. Hello. Hello, Sarah. Hello, are you there? Thank you for your attention. The presentation is over. I've come to the conclusion.
Thank you very much for your presentation. Any questions?
If there are no questions, even by email, I'm available. I think the presentation will be shared to all those who need. Thank you.
Thank you once again, Dr. Murphy, for your presentation. So we are moving on to the next presentation now by Dr. Jontini Munir Ahmad from Kusiang Medical University, Taiwan. The presentation title is Metal Biosorption by Exopolysaccharides Produced by Bacterial Strains Isolated from Marine Hydrothermal Vents.
Hello, good afternoon, everyone. My name is Janthini Munir.
It is my turn. Not yet my turn.
Okay. I'm doing PhD in Department of Medical Laboratory Science and Biotechnology, Kaohsiung Medical University, Taiwan. Today I'm going to present my poster titled Metal Biosorption by Exopolysaccharide produced by bacterial strains isolated from the marine hydrothermal vents. Now I would like to give a short introduction of this study. Shallow water hydrothermal vent fluids have a great impact on ocean chemistry through Sorry. Through process mediated by hydrothermal plumes, HVs produce large amount of hot fluids with high heavy metal loads with either toxic, for instance arsenic, cadmium, copper, or provide rare earth elements and other elements uh, which are leaching out of the rocks. With increased temperature ranging from 10 degrees Celsius to 100 degrees Celsius, microorganisms such as bacteria, fungi in this environment can tolerate extreme environmental situation, and these mechanisms were developing for the past million years. Their ability to detoxify heavy metal ions or to promote transformation to less toxic form has gained environmental attention among scientists. Microbes in this extreme environmental situation have developed an efficient strategies such as production of microbial fluid, for instance exopolysaccharide, which act as a defense mechanism against the toxic effect of metal in heavy metal contaminated environments. Microbial cells provide protein, lipids, and polysaccharide with many metal binding groups such as amino groups, carboxyl, sulfate, and phosphate group that provide effective bioabsorption matrices. In marine organisms, exopolysaccharide plays an important role for survival conditions, especially in extreme environments such as high salinity, pressure, temperature, heavy metal content. The bioabsorption of heavy metal by microbial exopolysaccharide secretion could provide bioabsorption for other elements as well as for more mobile earth alkali metals. So in this study, we hypothesized that hydrothermal vent associated bacteria have high heavy metal tolerance as an adaptation to their extreme environment that comes along with high adsorption capacity. The present study highlights the metal bioabsorption capacity and metal chelation ability of the hydrothermal vent associated bacterial exopolysaccharide extracted from the four hydrothermal vent associated bacterial strains, namely Excobacterium aquaticum, Mammalia-Coccus curi, Micrococcus luteus, and Geotoplycoccus huaqui, toward seven different metals such as arsenic, copper, cobalt, chromium, lead, nickel, and cadmium. In the study, we followed the methods. We isolated the bacterial strains from the hydrothermal vents, and we inoculated the four different bacterial strains in the optimized medium with and without metal ions. We incubated the culture for 48 hours to 96 hours. We extracted the EPS. We purified the EPS by using dialysis bag method, and we get the EPS by lyophilization method. After extracting the EPS, we did the characterization studies by FTIR analysis, and we did the bioabsorption of metal study by using EPS in an aqueous solution. We optimized the bioabsorption study by using we optimized the pH and contact time of the bioabsorption study. Uh, we did the analysis by using the ICP-MS method, and also we studied the adsorption isotherm study by using Friendly and Langwimmer model. The results This is the results of this study. First, we optimize the carbon source for the EPS production. Why we did this carbon source optimization? Because carbon source is an important thing for EPS production. So we use different carbon sources like glucose, inositol, xylose, arabinose, mannitol, sucrose, and ramenose. In this study, we found out that xylose, arabinose, and glucose have given more EPS byproduct than other carbon sources. So we took xylose for further study. And in figure 2 we did the EPS production of 4 bacterial isolates. In this study we took 5 different amount of liquid medium for checking the how much amount that the EPS is produced by the bacterial strains. We get more amount of EPS in 2.5 liters of culture. In figure 2b represent the EPS production of bacterial isolates in the metal amended conditions. In lesser metal amended condition, the EPS production is more, and the higher amount of amended condition, the EPS production became less. This is why, because the stress is more in the environment, so the bacteria adapt to the environment, so it stopped the production of EPS. That's why in higher concentrated of metal amendment condition, the EPS production is less. Figure 3 represent the SEM and EDX and elemental mapping of four bacterial strains EPS secretion with and without metal ion condition. In control, you can see the bacterial strains present in its original form. In metal amendment condition, the bacteria cell wall get ruptured and the EPS production i- is produced by the bacterial strains. In confocal laser scanning microscope, images show that higher concentration of metal amendment condition shows the reduce the bacterial growth than the lower concentration of the metal ions. The FTR in figure 5 FTR analysis of EPS, and in A you can see the EPS characterization without metal ions, and in B you can see the EPS with metal ions. This functional group uh, shows that EPS functional group in the EPS structure is the main reason for the binding of metal ions in the surface of the EPS. In figure 6, we did the total carbohydrate estimation by phenol sulfuric acid method and protein estimation of EPS by BCA assay. In figure C, you can see the DPPH assay of EPS and IC50 values of DPPH assay. In this carbohydrate estimation, you can in larger amount of EPS concentration, the more we found out the more carbohydrate content. This represent that the EPS has more carbohydrate content than protein content, which shows that the EPS could be a bioabsorption material for heavy metal ions. Figure 7 represent the removal efficiency of metal ion by EPS, and Figure B represent the adsorption capacity of metal ions. In this test, we use different metal ions like arsenic, cadmium, copper, chromium, lead, and nickel to find out which metal ions are absorbed by the EPS. In this test, we found out that Exicobacterium aquaticum shows more adsorption for arsenic, and Mammalia curie showed more adsorption towards cadmium, and Micrococcus luteus showed more bioabsorption towards copper, and then Geotoclicoccus vacui showed more adsorption towards nickel than the other three metal ions. So we took out these metal ions for further adsorption study. We optimized the pH and contact time for the adsorption study. In this, we found out that pH 5 and longer contact time is the stable condition for more adsorption of metal ions. We did the Freundlich adsorption and Langwimmer adsorption study for the EPS model. In this, we found out that Langwimmer Langmuir model fits the adsorption study. So, in this conclusion, in this study, we focused on the bioabsorption capacity and metal chelation ability of the EPS with metal ions. Carbon source optimization and metal amended condition increased EPS production. The EPS characterization in this study revealed a relatively high carbohydrate content, then little protein content. The bioabsorption efficiency to demonstrated that bacterial isolate showed maximum absorption of arsenic, cadmium, copper, and nickel compared to the other studied three heavy metal ions. The absorption behavior of EPS for metal ingestion is primarily affected by the pH and contact time. In our study, Langmuir and Friendly isotherm models were applied to study the absorption parameter for arsenic, cadmium, copper, and nickel. The Langmuir isotherm model provided a better fit at the increased metal ion concentration. Hence, the maximum metal absorption EPS of 4 bacteria strains suggested their ability as a bioabsorbent of metal ions. So, further study is needed. Like we would like to know how these metal ions are reduced into higher forms to lesser toxic forms. Thank you. Thank you for giving this opportunity.
Hello.
Yes, Sarah.
Yeah, your presentation is done.
Yeah, yeah.
Okay, thank you very much for your poster presentation.
Thank you. Do
Any
you have any
questions?
questions?
Good morning. Can you see my screen now?
Yes, but it's not the poster. We can see the screen, but it's not the poster.
What about now?
Yes.
Okay.
So the next presentation is a poster from Jadid Fatin from University of Badji Mokhtar, Annaba, Algeria. The presentation title is Impacts of Aggregate Quarries on the Environment, in particular the Atmosphere, Dust Impacts, Case of Heliopolis Guillemot Aggregate Quarry.
Thank you. Good morning, everyone. This is Fatin Jadid. I'm PhD student from University of Badji Mokhtar, Annaba, Algeria, Labamin Laboratory Mining Department. I'm so glad to be here with you today to present my scientific research about the impacts of aggregate quarries on the environment, in particular the atmosphere. Dust impacts. Case of Heliopolis Gelma aggregate quarry, Algeria. So we have the table of contents. Firstly, we will have the highlights, introduction, the study area, the current definition, the methods and materials, the results and discussion, and finally we will have conclusion. We will highlight the most significant side effects of mining, assessment of the environmental condition of the aggregate quarries in the study area, preserving the environment and achieving sustainable development and health safety. Introduction. The overexploitation of natural resources through quarrying and mining has led to the emergence of many negative effects on our planet, such as air pollution, which has naturally exacerbated cases of respiratory diseases and changed ecosystems. So, in our presentation, we will present the most important results obtained about the air quality change at the level of aggregate quarry of Heliopolis. Now, we can see the study area zone is located in the eastern Algeria, about 5 kilometers from the northwest of for the northeast of the agglomeration capital of Gelma. We can observe in this picture of Google Maps that the aggregate quarry is very close to the city of Heliopolis, less than 1 kilometer. Quarrying. Quarrying really on the extraction of mineral materials directly from the surface, based firstly on removing the vegetation cover from trees and plants. Then the miners will start the application of drilling and blasting techniques in order to explosive the mineralized zone, and after that the aggregate rocks will be conveyed to the crushing and grinding stations, which generates a huge emission of mineral dust. So, to understand this phenomenon, the present study was carried out on the large quarry through knowledge of the sedimentary environment, then quantification of dust degraded by the quarry. This picture shows the gravel quarry of Heliopolis Genma, which composed of many minerals like dolomite, clay marl, and iron oxide. Methods and materials. The study of sedimentary environment. The sedimentary approach consists of studying the working phase to the quarry and taking samples from the different levels of lithological and chemical analysis. The study of dust. The study of degraded aerosols interests us both from the quantitative and qualitative point of view in this process of pollution by dust. We distinguish two dynamic transports and deposits both are conditioned by the wind speed and grain size. Quantization. The approach followed to quantify the dust consists in taking samples of sedimented deposits in the 0.22 meters surface bands. They are placed in the 7 stations around the emission center. Station 1 is located in the interior of the quarry. The other stations are respectively installed at 10 meters, 20, 14, 60, 18, and 100 meters in the directions west-north, northeast, and east. The choice of distribution is based on the direction and the power of wind. The samples were taken in winter 2022. Results and discussion. As is mentioned in the Table 1, we can see that when we approach to the aggregate crushing seat, the dust measurements increase very quickly. So this shows that the environmental impact factor is very high in relation to the process of treatment of aggregates. Accordingly, will affect significantly and seriously on human health, for the information that the area where this quarry is located is an agriculture area, so we found that the dust covered the surface of the plants surrounding the quarry, which disturbs the process of photosynthesis and thus lead the weakening of agricultural production. As we see here, the station 3 and 4 are the most polluted stations, with PM 2.5, 143 micrograms and 515 micrograms. We can see here the dust emission during the crushing operation of gravel. After the XRF analysis of dust, we found that this dust composed mostly about the dioxide, silicon dioxide, the calcium oxide, the magnesium oxide, and the iron dioxide, and the aluminum dioxide. For the XRF analysis of dust, we found that the element of calcite is the most present element in the dust. then the dolomite, the siderite, the quartz, and the pyrite. This is just a video shows the drying and the blasting operation during the exploitation of aggregates. I don't know if you can see the video. We have here the graphical abstract of this subject. The Curie dust can affect the nearby ecosystems by the effect of the wind direction, and can affect the nearby ecosystem and the trees and plants, the fruit trees especially. These are some survey: 15% to 35% are increased to 58% the rate of respiratory diseases in the study area. Ways to conserve the planet: reduce the exploitation of natural resources, reusing the stones resulting from the collapse of buildings for use on other facilities. Volunteer participates in voluntary work to protect the environment. Plants: it is better to plant trees resistant to air pollution that are not fruitful. Excuse me. Inclusion: we all have the right to inhale a pure air, so we have to conserve all planets, the landscape deformation and the loss of the panoramic view, the migration of the nearby habitats. For life, the Curie dust inhalation can threaten the respiratory health of humans and even animals. For resources, the side effects of aggregate Curies can change water quality and groundwater quality, generating a serious danger for drinking water resources. This is the bibliography. Thank you for your attention. Any questions?
Thank you very much, Judith Fatin, for your presentation. Any questions?
I guess not. Thank you for your attention again.
Okay, so we'll move on to next presentation by Dr. Hao from Recycon KU Leuven campus Brugge from Belgium. The presentation title is The Use of Mixed Recycled Aggregates in Concrete, the Influence of Water Compensation Method on Physical and Mechanical Properties, freeze-thaw performance of concrete respectively.
You see my poster?
Yes.
Okay, thank you. So firstly, thank you for attending my poster presentation. My name is Hao Yuhao, and I'm from KU Leuven Bruges campus. Today, my topic is about the use of mixed recycled aggregates in concrete, influence of water compensation method on physical and mechanical properties, freeze-thaw performance of concrete, respectively. First of all, let me give you some very basic information about the background. As I mentioned in the topic, we focus on use of mixed recycled aggregates in concrete. So firstly, what is mixed recycled aggregates? It's actually a kind of material sourced from the recycling of construction and the demolition waste. The use of mixed recycled aggregates can help to save natural resources, and help to avoid potential soil and water pollution. But before we use this kind of material in concrete, we need to know that's the difference between it and the natural aggregates. Mixed recycled aggregate has a much higher water absorption than natural aggregate because it's more porous. It contains concrete rubbles and unbound aggregates, bricks, tiles, asphalt, and many different kind of actual rubbish in it. Just because of its high water absorption, if we just treat it as the same as a conventional concrete with natural aggregates, it can absorb a large amount of water from the mixture, and thus to cause a lower flowability of the concrete. This is not what desired by us. So some people may like to add some extra water into the concrete mixture to compensate for the loss of flowability. Actually, already some studies have already investigated the influence of the water compensation methods, but these were primarily focused on factors like slump and strains. Very limited research has been conducted on the impact on concrete durability. Here we incorporate this part inside. And then it's the objective of this research. The research aims at investigating the feasibility of making good quality concrete with MRA and to investigate the influence of water compensation methods on the concrete performance. 4 properties are investigated here, including initial slump, the compressor strength, frost resistance, and bulk electrical resistivity. The bulk electrical resistivity is a kind of indirect index to predict the durability of concrete. Next part is about the methods. Firstly, about the research parameters. Actually, this part consists of 2 major parts, 2 major factors. The first one is water compensation, and the second one is replacement ratio of natural aggregates by mixed recycled aggregates. For the water compensation, it has 2 small factors, volumes and methods. Volumes means how much water, extra water, we should add to the mixture to compensate for the water would be absorbed by mixed recycled aggregates. We have 2 options here, 100% and 80%. These are calculated based on the water absorption test of MRA in pure water. And for the methods, we have 2 methods here, additional free water methods and pre-wetting methods. The 2 methods are illustrated at the right side, the 2 pictures here. This is the additional free water method. What is additional free water? Just we add some extra free water together with the water originally designed for the conventional concrete and use oven-dried aggregates and put them together into the mixer and to make the concrete. And for pre-wetting, actually, we pre-mix the extra water with the oven-dried aggregates 1 day in advance to get a kind of a moisture equilibrium, and then use this kind of a pre-wetted aggregates directly in the concrete production. Yeah, it's about the replacement ratio. We use 25% by volume and 50% by volume. And these parts are the abbreviations of these factors, these parameters. And the naming of these mixtures, concrete mixtures in this research is a combination of these abbreviations. And as I mentioned, 4 major properties were investigated here. They are conducted according to relevant standards, and most of them are European standards, and except for this one, electrical resistivity, is according to American standards ASTM-C 1876. These are the test setups, illustration of test setups. And then we come to the results. The first graph is about the initial slump value. We have 2 small points to analysis here. The first one is about like 100% of compensation water can cause higher initial slump than the reference mixture. This one is the reference mixture. This one is the reference mixture. As we can see here, as long as we use mixed recycled aggregate in concrete, yeah, the initial slump show a higher value than the reference mixture. So that means, yeah, 100% extra compensation water cannot be fully absorbed by the aggregate when it's wrapped by the cement paste. But when we use 80% of compensation water, we can see that here it's almost a constant, nearly constant. So that means 80% compensation water is right enough, not too much, not too less, for the aggregate to fully absorb the water. The reason behind this phenomenon is because the 100% compensation water is actually calculated by the water absorption test in free water. And in the concrete, the aggregates are wrapped by cemented paste. It's drier than free water, much drier. So it's more difficult for aggregates to absorb water. So there should be a discount. And we find that 80% is right enough. The second graph is about the compressor strains. As we can see from here, F means additional free water and the S is the pre-wetting method. Two different kind of methods. From this method to that method, it's an upwarding trend. So that means like pre-wetting methods show a better results than the additional free water method. When the replacement ratio increased from 25 to 50, it's the same, shows the same trend between different water compensation methods. So we can conclude, we can say here that compared with pre-wetting method, additional free water can lead to a higher reduction in concrete strains. That means additional free water is worse. The third and the fourth graphs are about the freeze-over resistance of this kind of the concrete mixtures. Firstly, we just check the limits in the standards. At 28 freeze-off cycles, we can see here this is about mass loss, this is about internal damage. With freeze-off cycles, it's evaluated by the relative dynamic models of elasticity in percentage. For the mass loss, at 28 cycles, the standard says it should be like lower than 500. As we can see here, almost all the mixtures are between 50 to 100. So that means all the mixtures meet requirement. And here it's the same. The standard says it should be higher than 75%, and we can see that all the mixtures meet requirement. So firstly, we notice that both mass loss and internal damage meet the requirements. That means that concrete with this kind of mixed recycled aggregates can be used, has the potential to be used some freeze-off environments if there is no de-icing salt exist. And secondly, it's about the comparison between two different compensation methods. And we find here that pre-wetting methods show better freeze-off resistance than additional free water methods. And we can see it from this graph that the red and the blue one are with additional free water methods. They show higher mass loss. That means more serious deterioration. And the next is about the influence of the volume of compensation water. We find that 80% of additional free water scheme show better freeze-off resistance than 100%. So this is the same reason as we explained in the initial slide, just because of with the 100% additional free water, more free water existed in the past and led to a rise in the water cement ratio. And here is pictures about the failure spacements. We can see here, consistent with this graph, meet the requirements of the standard. We can see here at least no aggregates exposed at all. So that means this kind of concrete should a good resistance to freeze-off damage. And at last is about the electrical resistivity and indirect index for concrete durability. We find that for the reference mixture, it shows the highest value, but for all the rest mixtures with 50% replacement ratio and different water compensation methods and volumes, they just close to each other. So that means like water compensation methods has very limited influence on electrical resistivity. Based on the analysis and results above, we can get four conclusions, major conclusions as follows. Firstly, it's about 100% additional free water plan can lead to higher slump, lower strength, and worse freeze-off performance, and this kind of water compensation methods and volume should be avoided in practice. And then it's about the water compensation method. Pre-wetting is better than additional free water methods, no matter 100% or 80% of compensation water is used. But here we should notice that if the industry wants to choose appropriate methods, besides the performance, they should also consider the time we need to spend on preparing the materials, because the pre-wetting methods can consume a bit longer time and maybe a bit more complicated. The third conclusion is that concrete incorporated with coarse mixed recycled aggregates has the potential to be used in freeze or exposed environment without salt. And at last, bulk electricity is not sensitive to water compensation methods. So yeah, that's all my presentation about this research, and the references can be scanned, yeah, the QR code, and you can find the references. So that's all. Thank you. Hello? Hello?
Hello, thank you very much for your presentation. Any questions? I hope there are no questions. We are moving on to the next oral presentation by Sangeeta Tiwari from MIT University, India. The presentation title is Modification and Surface Functionalization of Fly Ash for Various Applications.
So sorry. Am I audible now?
Yes, you are audible, but your PPT is not visible.
Yes, I'm trying to share it. Just give me a minute.
I messaged you in the chat box. Please check it.
Okay. I don't know what. Share screen. Share. Is my presentation visible?
Yes, you can start.
Okay. Just a minute. My Wi-Fi is slow. It is taking time. Just, I'm so sorry for it.
Okay.
I'm not able to see my presentation. Is it visible to everybody?
Yes.
Okay. But it is, I don't know, it is some view is, yeah. Yeah, now I think you can see the first slide,
Yes.
title slide. Yeah. So first of all, I want to thank the organizers for giving me this opportunity to present my work in front of all the leading scientists of the world. And the title of my presentation, as you all know, is Modification and Surface Functionalization of Fly Ash for Various Applications. I'm professor in chemistry and head of the academics in Amity Institute of Applied Sciences, Amity University, India. First of all, I'd like to talk about fly ash. I think many of you may be knowing what fly ash is, but still, for those who are not aware of it, let me share that fly ash is the finest of coal ash particles produced as a byproduct during the production of electricity in thermal power plants. It is called fly ash because it is being transported from the combustion chamber by the exhaust gases. Fly ash is a fine spherical shaped glass-like particles, heterogeneous in nature, whose size varies from 0.01 to 150 microns. You can see in the picture, there is a micrograph, that is scanning electron micrograph, where the morphology of the fly ash particles is visible at 2000 magnification. These micron-sized particles consist of silica, alumina, iron, along with traces of oxides of sodium, magnesium, calcium, phosphorus, potassium, titanium, and also the non-combustible matter in coal, and a small amount of carbon that remains from incomplete combustion of coal. So the main constituents are silica, alumina, and iron. Uh, the problem with fly ash is that a huge amount of fly ash is produced, and it poses a problem of disposal. Near the thermal power stations, a large area is flogged with the heaps of fly ash, and consequent upon increased generation of electricity through thermal route involving combustion of pulverized coal, concurrent generation of fly ash in bulk quantities is a matter of serious concern, not only because of issues associated with its disposal and utilization, but also because of its threat to public health and ecology. The environmental problems with fly ash are: a large quantity of fly ash is dumped into poorly designed and maintained ash ponds. About 1 billion tons of this toxic ash lie dumped in these ponds, polluting land, air, and water. All the heavy metals found in fly ash like nickel, they're very, very small amount, but these metals are found in fly ash like nickel, cadmium, arsenic, chromium, lead, etc. And they're toxic in nature. They leach into the surrounding soil and can enter food chains. Fly ash gets easily ingested through respiration, which causes many diseases such as asthma, neurological disorders. Suspended fly ash in the air acts as a global warming agent and heats the Earth's surface. Another problem is that it settles on leaves and crops and reduces crop productivity. It also pollutes groundwater, reduces visibility by creating dense fog in the winter season. So these are the environmental problems which are posed by the accumulation of fly ash near thermal power stations. And regarding its current status, that is production and utilization, in India, mostly 70 to 75% on coal-based thermal power plants, which annually generates 235 million tons of fly ash and is projected to exceed 1,000 million tons by 2031 to 32. Over a period of last 20 years, the image of fly ash has completely changed from a hazardous waste to resource material. This is achieved due to the focused thrust provided by fly ash machine. In India, the government of India has a department of Science and Technology, which has a department fly ash mission, and it has a fly ash unit which works on promoting the technology for utilization of fly ash. And because of their effort, the fly ash, which was earlier known as a hazardous waste, is now known as a resource material. Fly ash is being used in all the fields, whether as a whole or in parts. It is being used in the form of cement for road reclamation and low-lying areas, road embankments, mine fillings, ash dike raising, bricks and tiles, agriculture, concrete, and others. These all make result in bulk utilization of fly ash, because a lot of fly ash can be used when in these applications. But still the major portion of the fly ash is being used only for the civil and constructions, which include cement, mines, fillings, concrete, bricks and tiles, road embankments and reclamations. But like uses like in agriculture and metallurgical purposes, it is still being used in very less amount. So the emphasis in India is towards the utilization of fly ash for low and medium value applications, like I talked about the bulk utilization. But efforts have to be directed to development of other commercially viable products, which may yield high value addition to its manufacturers. And we call these applications as value added applications. Such applications include metal extraction and use of fly ash as raw material for certain high value added products. These kinds of products, though consume very low volume of fly ash in absolute terms, however, have the potential in yielding considerable sales revenue for their end products. So some of the applications I have shown here through this diagram. You can see that traditional utilization is in bulk utilization, but regarding the value added application, less work has been done and needs more focus. Now, what our research group's contribution is to fly ash utilization, we have done a lot of work in this field. Various areas we have tried to utilize fly ash, and as in value added applications. For example, one is we have tried to utilize fly ash as an extender in paints and coatings. Another type of work which we have done is, I've not mentioned it here, we have also prepared zeolites from fly ash. That is, they are you all know what zeolites are. So we have also prepared zeolites from fly ash by new synthetic methods. And then third is modification and functionalization of surface of fly ash for various applications, like we have used it as modified fly ash as NIR reflective pigment. NIR means near infrared reflective pigment. Another use of modified fly ash we have done is as a base for nano photocatalyst, and one more use is as a base for NZVI, that is nano zero valent iron, for removing arsenic from water. So for water purification applications, we have used fly ash, we have used it for paints, we have used it for near infrared reflective pigment, or you can say heat reflective coatings, and as for photocatalysts. So various uses we have worked on, but here I am going to talk about only about one use, because there is a limitation of time. So I will be talking about only about my work on fly ash modification for use as NIR reflective pigment. Now, the basis or the reason behind this study is that unprecedented increase in energy use is actually a ticking time bomb. Rising energy cost is a driving force in development of new technologies designed to improve energy efficiency. Energy efficiency helps control rising energy cost, reduce environmental footprints, and increase the value and competitiveness of buildings. Traditional colorants used in coatings generally absorb visible as well as near infrared spectra, which gets converted into heat and causes environmentally undesirable macro effects such as heat islands. So the concept of NIR reflective coatings is that the sun's energy that reaches the Earth's surface is divided into three parts, that is UV, visible, and infrared. So the major part of the radiation which is responsible for heating is infrared, and the range is from 700 to 2500 nanometers. The majority of the energy in the infrared range is found in this region, and this is known as near infrared region, or NIR. The temperature of an object in an outdoor environment is determined by four main mechanisms like reflectivity, emissivity, convection, and conduction. Convection is largely dependent on airflow, and conduction depends on how well an object is insulated to prevent heat flows. Now, reflectivity and emissivity are the factors that can be manipulated. Reflectivity can be manipulated by careful selection of high IR reflective pigments. The key is to reflect infrared and absorb and reflect in the visible region to produce the needed color. So advantages of these kind of coatings are they keep the surfaces cooler by reflecting the solar radiation. So if you apply these NIR reflective coatings on the buildings, the temperature of the inside of the building will be less as compared to if you're not coating with these coatings. So there is a reduction in the temperature, and therefore the use of ACs and for air conditioning is reduced, thereby reducing the energy cost. So thermal stress is reduced in construction. Another advantage of using these coatings is thermal stress is reduced in construction materials, and it protects the environment and limits urban island effect. Reduction in air pollution due to lower energy usage, because we are using less air conditioning, so air pollution is also less. Power plant emissions and a reduction in urban air temperature. Traditional NIR reflective pigments which are generally used means in commercial coatings which are already in use. Some examples are given here, like highly engineered ceramic pigments, also called mixed metal oxides. Then complex inorganic colored pigments based on rare earth oxides are generally used as NIR reflective pigment. Then nanocrystalline titania is known to have a very good NIR reflectivity. These pigments should be dispersed in selected polymeric binder, example solvent bond, air dry acrylic, to achieve full dispersion and optimum properties. So these are the traditionally used pigments. Now what we have done is we have synthesized a new NIR pigment by growing nanostructured titania on fly ash. So since titania is already known to have good reflectivity, and by coating over fly ash, we are reducing the cost of this pigment and achieving the same level of reflectivity as in titania. Another benefit is that because you know that if we use nano titania in the paint or the coating, then dispersion of nano titania is very difficult because aggregates are formed, and proper dispersion is not achieved. But when we use these core shell structured pigment, because these pigments what we have prepared have a core shell structure, that means fly ash we are using in the core and titania is coated on the top of the fly ash particle. So these core shell structured pigments, they are not nano sized because fly ash is not nano sized, so dispersion is also easier. Now the coating of titania on fly ash was done in multi layers. That is, it is not only single layer we have coated, but we have coated in double or triple layers, and then we have checked the reflectivity of the pigments. Selection of the material, what we have done is the role of fly ash as a core. Why we have selected fly ash in the core? Because it is known to have a good extender properties. for coatings, which will have additional benefit if rendered NIR reflective property. Fly ash possesses poor thermal conductivity, due to which it will prevent heat conduction to the substrate. Low cost and easy availability of fly ash as compared to other. So fly ash otherwise also can be used as an extender without any modification. This work also we have done. We have prepared paints out of using fly ash as an extender. But then if we prepare these kind of material by coating nano titania, then it will have an additional benefit of producing heat reflective coatings. Now, what is the role of nano titania? It is known to exhibit remarkable light scattering and infrared reflectance due to its high refractive index. However, smaller particle size and difficulty in uniform dispersion in coating limits its use. So this I've already told you that this drawback of dispersion is overcome in what NIR pigment we have prepared. Now the approach is what approach we have used is diagrammatically represented here. First, we remove unburnt carbon from the coal, because fly ash has got a gray color, and to improve its color and to make it more whitish, we have to remove the unburnt carbon. And then we remove the colored oxides of iron also, and we get a improved whiteness in fly ash. And then we do the coating of fly ash with we modify the surface of fly ash using surfactants, and then coat the nano titania over it, and then those pigment is used to make paints or coatings. Now synthesis of these fly ash at the rate nano titania, we have used two methods. One is a precipitation method, and another one is a modified ultrasonication method. And in precipitation method, what we are doing is we are coating a layer of surfactant over fly ash, and then we are precipitating the precursor of nano titania on the surface of the fly ash. And then same coating technique we are repeating 3 times to obtain a triple coated fly ash, as represented here as TCFA. But what there are some drawbacks of this method, and then we used an ultrasonication method, wherein we first disperse the fly ash, and then in situ coating was done on the surface of fly ash. And I will just show you what advantages this method has over the other one. You can see a diagram here. Here we have compared the two methods. The upper one, when we use this precipitation method, then the coating which is uniform, which is obtained over the fly ash, is not uniform, because the dispersion of the fly ash is not proper, and therefore the coating is not uniform. But when we use ultrasonication, a very uniform layer of the nano titania is obtained over fly ash, and you can see the difference in the result. SRI means solar refractive index. So in the first method, SRI value was 77%, which was drastically improved to 94% in the method where we have used ultrasonication. So a better reflectance was obtained. Now the same thing has been represented here also, how we have obtained uniform coating through ultrasonication. And this is the representation of multi-layered, how we have prepared multi-layered. You can see first surfactant, and then single layer, double layer, and third layer. Then this is the scanning electron micrographs of fly ash at titania. You can see the pictures for A and B are fly ash without any modification. Then C is the activated fly ash, that is where surface activation has been done. And then you can see activated fly ash, and then coated with titania. And after coating with titania, we have annealed the surface, because on annealing the rutile phase is converted into anatase. Then HR10 images, you can see in these images, one thing what we observed was that the surface of the titania layer is crystalline in nature. And another thing you can see in figure D, a very clear layer or the coating is can be seen. I have indicated it as core shell interface. So a very clear coating is visible in the HR10 images, which confirmed that coating was done and the coating obtained was uniform. Now this is the reflectivity test we have done. That is the diffused reflectance spectroscopy we have done to see the percentage reflectivity. And you can see in the figure that the fly ash annealed at 800 degrees centigrade has almost the same reflectivity as commercial TiO2. We have compared the performance of our pigment with commercial TiO2, and we found that the percentage reflectivity and solar reflectance obtained were very of our TiO2 coated fly ash is almost same as the commercial TiO2. Now this is the proposed mechanism. You can see that fly ash at the core and 2-3 layers of titania, and when annealing is done at 800 degrees centigrade, the particles fuse among each other, and then scattering is enabled because of the fusion of these particles. The scattering of light is obtained, which actually results in improvement in the reflectivity. So this is a proposed mechanism by us. We have proposed this, and then these results are for the coatings. Earlier one was shown for the pigments. Then we have prepared epoxy coatings using these pigments, and then again checked the reflectivity, and we have found that the pigment which is annealed at 800 has got a very good reflectivity, and it is as good as the commercial TiO2. So you can see in this table also that reflectance and emittance, and then SRI values calculated, and commercial TiO2 it is 95, and for fly ash titania coated fly ash it is 94, which is almost we have achieved reflectivity of that level. Now this is thermal diffusivity test. We have seen how much difference in the heat, means how much cooling it is producing. So we have indigenously used a wooden box, and we have painted the steam panels, and then seen that how much heat is obstructed by our pigments or our coatings. And you can see that there is a difference of temperature. The last column is showing the difference in temperature, and commercial TiO2 is able to achieve a reduction in temperature of 8.6 degrees centigrade, whereas our pigment it is reducing the temperature of inside of the building or the box which we have used, and the difference in temperature was 10.5, which is very good achievement. So these are the conclusions. A greener approach has been developed for preparation. Greener approach I'm saying because in the ultrasonication method we have not used any solvents. In precipitation method we have, but then further we improved the method, and a greener approach was suggested for preparation of cool pigment. A significant NIR reflectivity is achieved in composite particles and their coatings by designing particles with favorable morphology and crystallinity. The developed core shell particles possess high thermal emittance and solar reflective index. The cool coatings prepared using core shell particles displayed low thermal diffusivity in comparison to the coatings based on commercial titania. The coatings are multifunctional in nature as they show good photocatalytic property as well as antimicrobial characteristics. I have not shown those results here because of the lack of time, but these coatings also are antimicrobial in nature. The use of Fa at titania in cool coating applications would ensure reduction in the requirement of costly nano titania. It would be a cost-effective material since it utilizes fly ash, which is an industrial waste. So I thank Ministry of Environment and Forest for funding this project. And thank you very much for a patient listening. This is all from my side. If there are any questions, I will be very happy to answer them.
Thank you very much, Dr. Sankita, for your presentation. Any questions?
I think there are no questions.
Okay.
Thank you very much.
Okay, so there are no questions. So we are moving on to the next presentation by Urusa Izaz from Shahid Julfikar Ali, Bhutto Institute of Science and Technology from Pakistan. The presentation title is Use of Ionic Liquid Pre-Treated and Fermented Sugarcane Bagasse as an Adsorbent for Congo Red Removal.
All right. Thank you for the introduction.
You can
Is
start.
my okay? Is my screen visible to you?
Yes.
All right. Thank you. Okay. So my name is Usai Jas. I am a PhD scholar in microbiology. I am working as a lecturer at the Department of Biosciences, Zabis University, Karachi, Pakistan. The topic which I am presenting today is use of ionic liquid, pre-treated and fermented sugarcane bagasse as an adsorbent for Congo red removal. So textile industry is one of the biggest consumer of potable water, and there are many chemicals and dyes which are used during the textile processing stages. So, dyeing and finishing stages are the major producer of the wastewater, and that textile effluent contained many toxic metals and dyes. The unused dyes and chemicals are discharged in the form of the effluent from various units of textile industry. So if you look to this graph, here you can see that 85% of the effluent contained the dyeing amount, 62% of the effluent come from the bleaching unit, 58% from the wet finishing. So 70 to 20% of the industrial water pollution contained 70 toxic chemicals which are originate solely from dyeing processing unit, and there are 30 those components which cannot be removed. So in order to uh, preserve our environment from the toxic pollutants, we have to make the pre-treatment process, because the dye containing effluent can harm our environment, it can harm aquatic animals, it can harm plant species and human beings. If we talk about the environment, the textile effluent can result in toxicity, it can increase the chemical oxygen demand and biological oxygen demand, which are COD and BOD. Uh, for the plant species, the dye effluent can interrupt its photosynthesis process. It can also decrease the soil quality if we dump our textile effluent into the land area, and ultimately it is going to affect the plant growth. For the aquatic animals, it increases the level of danger because it is proved to be toxic for the fishes and other aquatic life. And for human beings, it is very hazardous. It can cause many diseases and it is carcinogenic. So you can have an idea that how toxic can be textile effluent is. And if we dump that textile effluent without any treatment, it's going to affect our environment and ourselves badly. So why there is a need for dye effluent treatment? Because the textile water is highly colored. It contains not only the dyes but the heavy metals, and it causes high electrolyte and conductivity concentration in the dye wastewater, which
Sorry
ultimately
for the
lead to
interruption. Please
yes,
change the slides accordingly.
yes, I am changing it.
But we are able to see the first slide.
Wait
You
a
need to
minute.
click on the slide.
Can you see the slide?
No, we are able to see the first slide. You need to click on the slide.
Wait a minute. Let me share my screen again.
Okay.
Is my slide changing now?
No, yes, it's changing now.
All right, thank you. So I was talking about the need for the dye fluent treatment because it contains high color amount, it contains heavy metals, it increase in BOD and COD level of the contaminated water. It is carcinogenic and mutagenic and very harmful to our environment. So there are some techniques by which we can decolorize the textile effluent. It includes physical treatment, chemical treatment, physicochemical treatment, and biological treatment. In this particular presentation, I am going to focus on the physical treatment method. So physical treatment is the method by which you can remove the substance by gravity, electrical attraction, van der Waals forces, and by other physical barriers. One of the example of physical treatment is adsorption. In the adsorption, you have a matrix, and on that matrix, the pollutant amount gets stick. So it is very efficient method of pollutant removal. There are two mechanisms: adsorption and ion exchange. And this adsorption method is basically influenced by other factors: surface area of the adsorbent, particle size of the matrix, pH, and the contaminated water. So in this study, we used sugarcane bagasse, which is the waste product of sugarcane industry. The bagasse was fermented by using a microbial species, Bacillus pasteurii UE25. This bacterial strain can ferment the sugarcane bagasse for the production of valuable enzymes. One of the enzymes is cellulase. So after the process of fermentation and obtaining the thermostable cellulase enzyme, the fermented bagasse was used as an adsorbent for the Congo rat removal. So here you can see when the Congo rat is adsorbed by the sugarcane bagasse, in the end we got the clean water, and that clean water can be used for the plant irrigation. So this is the basic methodology of this study. So when we observed the results, we found out that the untreated bagasse has quite compact structure, and the fermented bagasse has a very rough and porous structure. Here you can see the image of pre-treated sugarcane bagasse. In this study, before the fermentation process, we pre-treated the bagasse by using an ionic liquid, methyl trioctyl ammonium chloride, which is a green solvent. So pre-treatment method basically removes the lignin content from the bagasse so that the carbohydrate part, which is hemicellulose and cellulose, becomes accessible to the microbial stream. So when untreated, pre-treated and fermented sugarcane bagasse were used for the Congo rat removal, we found out that as we increase the concentration of Congo rat dye, the more percentage of the dye was decolorized. And in the case of pre-treated and fermented sugarcane bagasse, the maximum dye absorption was observed in comparison to the untreated bagasse. The isotherm kinetic study showed that the untreated bagasse followed the Langmuir isotherm model, and pre-treated and fermented sugarcane bagasse followed the Freundlich isotherm model. Freundlich isotherm means that the surface of the sugarcane bagasse was not homogeneous. It was heterogeneous surface on which the particles of the dye gets attached. The kinetic study of the absorption process was also performed, and it was found that the untreated and pre-treated sugarcane bagasse followed pseudo second order, and the fermented sugarcane bagasse also followed the pseudo second order model. The results of interparticle diffusion kinetic model showed that it was not a linear process. Instead, there were two processes, primary and secondary, by which the congruent dye get formed on the bagasse surface. Okay, so thermodynamics study of dye adsorption was also performed, and in this study, three different temperatures were used: 303.15 Kelvin, 308.15 Kelvin, 318.15 Kelvin. And it was found that the maximum dye was removed at the temperature of 303.15 Kelvin for the fermented bagasse, and 98.358% dye was removed in case of pre-treated bagasse, again at 303.15 Kelvin temperature. Same goes for the untreated bagasse, which resulted in 90.363 Kelvin. The entropy and enthalpy, standard free energy of the dye adsorption process, were also calculated, and the negative results were observed for the entropy process, which means the process of endothermic, not the exothermic. So from this study, we can conclude that sugarcane bagasse is a matrix which can be used as a substrate for the production of valuable industrial enzymes. Like in this study, we obtained the cellulase enzyme by fermenting the bagasse component, and after the fermentation process, the leftover residue was used for the removal of congruent. So it is some kind of zero waste approach in which you are utilizing a sugarcane waste product for the production of enzymes, and after the production of enzymes, you are again reusing that leftover part for the dye removal process. The adsorbent's surface heterogeneity was explained by the Freundlich isotherm model, which I explained to you that it was the best fit model for the pre-treated and fermented bagasse. The adsorption process followed the endothermic, and it was live with the pseudo second order model. So this study overall provides a very cost-effective strategy to use bagasse for the production of enzymes and to remove the congruent dye, and ultimately it strongly supports the idea of reducing environmental pollution. So I would end my presentation with the quote of William, which is, waste is not waste until we waste it. So like in this study, we utilize a waste product bagasse for the valuable enzyme production and dye removal process. So join the green revolution and stop pollution to save our environment. With this, I will thank the organizing committee for inviting me this talk, and I want to thank all the participants for listening. Thank you.
Thank you very much for your presentation, Dr. Urusa. Any questions? I'm sorry for the inconvenience. So, we came to the end of day 2 sessions. So, there are few missing presentations, but they couldn't make it because they're not feeling well. And thank you each and everyone for joining the sessions on day 1 and day 2 and making it a successful one. And I'll be sending you the certificate of participation and the conference soft copy book at your email. Please do check and reply me that it's received in a good way without any corrections. So I would like to let you know about the next conference. The next conference on environmental sustainability and climate change, recycling and waste management. It's a 7th annual conference to be held in New York, USA, and the dates are August 19 to 20. I'll be sending these details at your email as well, and let me know your interest to join the next conference in person. Thank you, one and all. Have a good day. Bye bye.
Thank you, Madam Sarah.
Thank
I'm
you.
just, I want to say, to confirm that the certificates of participation that I have made, I
Yes,
have
the
made,
certificate will be sent to you by email.
yeah, just the title of presentation. I want to make a virtual online presentation, not a poster, please. All right?
Okay, online presentation. Is it right?
Yes. Thank you so much.
Okay.
Thank you all.
Thank you.
Okay.
Sarah, thank you so much.
Thank you. Hope to see you in person in the next conference.
Is the next conference is New York, right?
Yes,
This year or next year?
New York, USA.
Yeah, as which term specifically?
August 19 and August 20.
Okay, next year.
2024.
Yes.
Yeah, we
Yes.
hope to meet in person.
Yes. As we
Thank you
miss
so
your
much.
presence.
Yes, thank you so much. Thank you.
Okay,
Thank
thank you.
you.
Bye.
Bye bye.
Okay, Sarah. Thank you. Thank you, Sarah. Thank you so much. Bye, bye. Bye. See you. Bye.